पण नाही याच्यावरच बोला ना सर आता, कारण याच्यावर एक नाव तुमचं दिसेल, परत दुसरं नाव असं इथे करून घेऊ आपण व्यवस्थित, तुम्हाला पुढची वगैरे टाकून दिसेल असं.
काय नाही, एक मोबाईलची बॅटरी 5 मिनिटं थांबा.
Hello. गुड मॉर्निंग सर, आवाज येतोय का माझा? येतोय ना? तेच म्हटलं, दिसतोय म्हटलं, झूमवर पहिल्यांदा बघा. ठीक आहे, काही अडचण आली तर मी या फोनवरून करत जाईल तुम्हाला. गंजेवर सर बोलतोय सर. हा हा बरं पहा ना सर, म्हणजे स्क्रीनवर दिसतोय ना मी तुम्हाला. हा हॉस्ट कडून डिसेबल्ड झालं म्हणाले. दिसतंय. ओके सर, थँक्यू. हॅलो.
All the dignitaries, research persons, research scholars, research followers, on behalf of the college,
Sir,
and as the head of the department.
आवाज नाही येते. अनम्यूट करा सर. कॅमेरा चालू करा आणि
Continue. And good morning to everyone. Myself, Dr. Elvizar. On this occasion, I would like to welcome all the dignitaries, research persons, research scholars, and research fellows on behalf of the college and as the head of the department. Friends, from the last 3 to 4 months, we are facing the pandemic situation due to the COVID-19. Due to this, all the colleges, universities, research centers are closed, and the education system is much affected due to this COVID-19. There is a massive loss of the study of the students, and to avoid this loss of the career, education of the students, our chief patrons, Honorable Prakash Dada Solanke Sahib, MLA, ex-State Minister, and President of MSP Mandal Aurangabad, and the Honorable Satish Bauchan Sahib, MLC, Secretary MSP Mandal Aurangabad, and other patrons, especially Honorable Sri Jaising Singh Bhaiya Solanke Sahib, President of CDC, and other members, Honorable Sri Lauhaji Chauhan Sahib, member of CDC, Honorable Sri Ajay Singh Dikhat Sahib, member of CDC, Honorable Sri Indrajit Jadhav sir, member of CDC, and Honorable Dr. Ram Shingare sir, member of College Development Committee, and Honorable our ex-principal, then now member of the College Development Committee member, and my colleagues and vice principal, Honorable Sri M. Jogre sir, Honorable Sri Dr. M. Gaikwad sir, and also I would like to mention the special names of my colleagues, Dr. K.R. Desai madam, and the technical supporter who takes the large effort and kindly support and guidance, properly guidance, Mr. Sagar sir, GD Sagar sir, and Gale sir. Thank you for them. Friends, all these respected dignitaries motivate us, inspire us to organize several curricular and extracurricular activities in the college. We are constantly engaged in these activities apart from our daily educational activities. Our chief patrons are the well-known popular leaders of this region, so they are aware for the career of the students, and as a result, we have organized today's web conference on the recent development in material science and nanotechnology, RDMN 2020. We all know that today the maximum research work is on the material science and nanotechnology, as this is a prominent important subject due to the wide applications in nanomaterials. That today the life without material science and nanotechnology is not possible. It is used in our daily lives, computers, efficient power sources, life-saving medical instruments used to protect the environment. Also, it is used in electronics and renewable energy instruments. The textile mills, this is the wide applications of the nanomaterials and nanotechnology, which are the mostly used in our daily lives. And therefore, by considering this wide range of applications, we have organized today's conference so that the students belonging to this rural area and the research workers, research scholars can be motivated and inspired to get new ideas for their future career. Friends, it is true that we should agree that the China is much leading than the India, and we have to compare with the China. That means we have to uh, enhance our facilities and the research facilities available, and therefore that can be achieved by organizing such a web conferences, and therefore to the students should get so strong need of India that our students can be constantly engaged to achieve the desired developments. And by this, we can be really the self-independent. Therefore, for this are invited as a speaker, we have the Honorable Professor Dr. K.M. Jadhav sir, the Senior Professor of Dr. Babu University Aurangabad. The second the speaker is the Honorable Professor Dr. N. Ruhila sir, the Scientific Officer, Bhabha Research Center, Mumbai. Again, we have the Honorable Professor Dr. Vikas Patil sir, the Director School of Physical Sciences, Punyashloka Ahilyabai Holkar, Solapur University, Solapur. And also we have the Honorable Professor Dr. Vimal G. Gandhi, Associate Professor, Department of Chemical Engineering, Dharmsingh Desai University, Nadiad, Gujarat. And these are the well-known the speakers in their field, and we have invited these speakers. So, without losing any time, I would like to introduce our today's keynote addresser, Honorable Professor Dr. K.M. Jadhav sir. Friends, while we are talking about the resource work in the Marathwada state, we must consider his contribution with a great respect. Without him, we can't proceed. That means we have to consider sincere work of the Honorable Dr. K.M. Jadhav sir of this area, so that the maximum students of this area are get benefited. He has achieved milestones, and I humbly point out that I have completed my research work under his able guidance. Friends, our keynote speaker, Honorable Dr. K.M. Jadhav sir, is presently working as a professor in the higher grade Department of Physics, Dr. Babasaheb Ambedkar University, Aurangabad in India. He did his PhD work in the year 1993. He has completed his MSc degree in June 1985. And Honorable Sir has the teaching experience of 30 years, the of Physics for 3 years from April 2007 to 31st January 2010. The total teaching experience is nearly 30 years. The grade level period is 5 years. At postgraduate level, the 25 years of teaching experience, and the research experience is nearly 29 years. The research supervision, he guided a PhD student degree. Nearly 45 students have awarded the PhD degree under his able guidance, and presently the 8 students are working under his guidance. The research interest high temperature superconductors, the colloidal magneto-resistance material, magnetic nanomaterials, nanoferrites, nanofluids, bio-nanomaterials, ferric to thin films, ferroelectric materials, composite materials, glass and ceramics, ultrasonic studies of liquid mixtures, gamma and laser radiation, the research publications, the sir has the published papers in international and national journals. In international journals, he has published nearly 292 papers. In international journals and conferences, he has published nearly 192 papers. In all, he has published nearly 484 papers in different journals. Friends, index the citation of the paper publication is quite good, and the patents he gets, the total number of patents he gets 4 and granted is now 3. The innovation patent for the Australian government, the title for the patent which he get is a compound having chemical formula XBY EUV, EUX, a composite mode, their form and method of making the same. The innovation patent by Government of India in 2014. The research projects, the sir has completed the research project nearly 4, and the one project is going on. And the 3 projects have submitted to SERB, DST, BRNS. The sir has received the many awards, national awards and state awards. He elected Fellow of Maharashtra Academy of Science of Pune, Best Research Professor Award by Dr. Babasaheb Ambedkar Memorial University, Aurangabad, the Bharat Gaurav Award in October 2016, India International Friendship Society, New Delhi, Rotary Vocational Award, Rotary District, Rotary Club of Umarga and District Usmanabad. The Paryavan Bhushan Puraskar from Bharat Mata, Bahudyalaya Sanstha, Nardurg, and biographical note is included in popular Asia Pacific Who is Who in volume 14, published by Recipient International, life member of various research societies like IPA, MSI, IAPT, ISC, USI, MRS, and academic number of various statutory bodies. Sir has a gold and rest biodata, and he is not, like, apart from the academic activities, he is most popular for his calmness, patience, tolerance, and good monitor, great supporter, and has got good sense of humanism. He has a good sense of humanism. Therefore, he is most popular among the students and in this molecular region. I hope this is not enough data to describe for him. Now, I request the today's keynote speaker, Honorable Dr. K.M. Jadhav sir, to keynote address on the title Magnetic Properties for Waste Water Particles. Honorable Dr. Jadhav sir. Hello.
1 minute, sir.
मतलब जो होस्ट आहे त्याला अलाउ कर.
हा, इकडून आवाज जातो आपला, सांगा बरं.
हा सांग.
हॅलो हॅलो सर.
हॅलो, बोला सर.
ते शेअर स्क्रीन होत नाहीये, डिसेबल्ड केलंय.
नाही, परत एकदा प्रयत्न करा सर.
हो.
हॅलो.
हा, आला. ओके. कुठे? In the beginning, I would like to thank my student, Dr. L.B. Dadavar, for giving me a very big introduction. Thanks for his introductory given introduction of me. Good morning to all the participants who joined this webinar on the recent developments of the material science and
हॅलो
hello
आवाज येतोय का?
hello
सर येतोय आवाज येतोय.
येतोय ना? Okay, so very good morning to one and all, and warm welcome to all the participants who joined this webinar organized by the MSP Mandals Kille Dharur College on the topic of the recent advances in material science and the nanotechnology. Before commencing my speech, I would like to thank the organizer, the principal, Dr. Shirsat sir, Jawar sir, Dr. L.B. Dadar, the convener of this conference, Dr. Kirti Desai, co-convener of this conference, and all other faculty members who are taking efforts for the successful organization of this webinar seminar. Also, I am thankful to the president of this MSP Mandal, Dr. Sundarraoji Solanke, and Honorable Secretary Satish Bhav Chauhan for giving all the time opportunity me to interact with the institutions of the MSP Mandal, maybe from Devgiri College, Gangapur College, Darur College, all other colleges. All the time they support me and they give me a freedom to help and guide the teachers of the physics and other subjects in the MSP Mandals College. So once again, I am thankful to both of the dignitaries. Now my main presentation is on the magnetic nanoparticles and how these magnetic nanoparticles are helpful in the wastewater. One minute. The content of my presentation goes like this: the introduction, wastewater treatment, nanotechnology, magnetic nanoparticle, photocatalysis, results and discussion of nickel ferrite nanoparticles. Since the conference is on material science and nanotechnology, so I am working since last 25 years in the field of material science, and from last 10 years, I'm working in the field of nanomaterials, nanoscience, and nanotechnology. We prepare the various kinds of magnetic material and we try to explore them for various applications. For biomedical application, we have investigated some of the properties. For water purification, we have investigated. At the same time, we have investigated the antibacterial activity of the magnetic nanoparticle. So our focus is on the magnetic nanoparticle and their diverse application in various fields. So in today's presentation, I will focus my slide or my talk on how the magnetic nanoparticles are useful for wastewater treatment. I have chosen for wastewater treatment the topic. Now, since it is related to the water, in short, in brief, I will go through the various slides related to the water, how the water is get contaminated, what are the contaminants, what is the process of waste treatment. In the beginning, I will explain them, and then how the nanotechnology plays an important role in governing or in utilizing the magnetic nanoparticle for waste water treatment. Now, as all of you know that water is represented by the molecular formula H2O having 2 mole of hydrogen and 1 mole of oxygen. This is a basic, everyone knows it, and it plays a very vital role in our everyday life. Without water, no one can think of life on earth. It is impossible that without water, we cannot live on the earth. As per the statistics, the 783 million people do not have access to clean and safe water worldwide. The bad luck of our country and other societies that we cannot get a clean water which is for safe use, and that is our problem. Water is the most essential and crucial for all human activities. Sources of clean water are limited, but the demand is increasing. We'll see that we get a clean water from a limited sources like lakes, rivers, and other things, but our demand for the clean water is day by day is increasing. The sources of water are river, lake, through oceans also we may get by some processing the clean water. Groundwater, well and borewell are contaminated by many causes, microbes, bacteria, harmful chemical, pharmaceutical. So water we get from groundwater and borewell may be contaminated. Many of the severe diseases to human community like malaria, typhoid, cholera, viral hepatitis, skin diseases are the causes by contaminated water. So if you don't get a pure water, then the contaminated water may be harmful to our human body and many diseases can take place in the body. Over 75% of the Earth's surface is covered by water. 97.5% of this water is salt water, leaving only 2.5% as a fresh water. So you see that very few amount of fresh water is available to the humans. Nearly 70% of the fresh water in the ice caps of the Antarctica and Greenland. Most of the remainder is present as soil moisture or as groundwater, not accessible to human use. So some part of the water is frozen under the Antarctica area and it cannot be used for human. Less than 1% of the world's fresh water is accessible for direct human usage. So you will see that this is the statistical and proved by the scientific committee. So we get only 1% of the fresh water throughout the world, and it is very limited or it is very short. Where this safe water is used or the fresh water is used, you will see that 41% of the fresh water is utilized by the thermoelectric power. Then agriculture purpose, the 37% is goes on. 6% is for the industrial and commercial purpose. 14% for the domestic and public use, and 3% is livestock and aquaculture. So this is the distribution of the fresh water available to every sector of the field. Now what is wastewater? So we have talked about the clean water. Now we will see what is wastewater. Wastewater is a term that is used to describe waste material that includes industrial liquid waste and sewage collected in towns and urban areas that treated at urban wastewater treatment plant. So anything waste which is deposited in a water or a river or in any storage, then that is a wastewater. From where this wastewater comes? It comes from start from our home residence, from kitchen and from bathroom toilet it gets. Then animal excreta, commercial institutions, industrial establishment, religious rituals, festivals and celebration, and urbanization. So we are day by day increasing urbanization, industrial growth is taking place, and therefore the wastewater is also increasing. So in wastewater, number of ingredient and number of contaminants are there, and they may be the organic, inorganic, like that. So the organic contaminants which are present in the water are volatile organic compound, pesticides, phenolic compound, phthalate, nitrogen containing compounds are often detected in polluted water. So these are the organic contaminants present in water. The inorganic component are mostly the heavy metals like mercury, lead, chromium, nickel, cobalt, copper, cadmium, silver, arsenic, and all these are the toxic and harmful for the human body. Then pathogens are also contaminants of the water. Pathogens such as the bacteria, viruses, parasites may be present in very low concentration in drinking water, but cause many infections, diseases, and considered as one of the major risk factors with drinking water safety. In the today's scenario, due to the COVID-19, we see that many persons are dying, but if you compare the rate of dying person in India is very less as compared to the other countries. It may be because of that we all get contaminated water and thereby increases our immunity. So that is one may we take advantage of this contaminated water, but though it is the advantages, it is not good to use the contaminated water. Impacts of water contamination. So what happens? What is the impact? What is the resultant of this? So water get polluted. There is a loss of blue carbon sink. Ecological imbalance takes place. Biodiversity, loss of fishery livelihood. So fishes are there in the river and tanks, so they get died. And climate change. These are the impacts on the wastewater. Now, how to convert the waste matter? A process of converting wastewater, which is water no longer needed or suitable for its most recent use, into the influence that can be either returned to the water cycle with the minimal environmental issues or reuse. So wastewater can be treated and converted into the pure water. It is important to treat the wastewater. The reason for treating the wastewater is to remove the pollutants from wastewater. Various pollutants, we see that organic and inorganic pollutants are present. So that should be removed from the wastewater. To recycle the wastewater, we can, wastewater can be recycled. For example, in big industrial organization or in big educational institute, the wastewater is recycled and it is in use for the garden and other trees also. So to recycle wastewater, to promote health concern and public hygienic, to preserve aquatic life, wildlife habitats, to promote recreation and quality of life. So for all these purpose, we need to be treat the wastewater. Here is why there is a wastewater treatment. It is increasing population. So industrial area is increasing. So a lot of waste coming from the industrial area, and that is get deposited in the river and other nearby area. So climate is also changing. Prolonged droughts and floods are occurring because of this wastewater problem, depleting the water resources also. This is unsolved technology problems. You can see here how these contaminants of the water can affect it to the humans. Clean water drinking. In many parts of the world, access from certain area. Filtration of large volumes of water, however, is slow and impractical. Filtration is one of the technique for the clean drinking water, but it has some limitation it is slow and impractical. To counter these problems, scientists have introduced a new water purification method based on magnetic nanoparticles coated with a so-called ionic liquid that simultaneously removes organic, inorganic, and microbial contaminants as well as microplastic. So the conventional methods like filtration for the purification of water are not enough or not practical. So the scientists have worked and they have introduced new method on the basis of the nanotechnology. That is, they prepared the magnetic nanoparticle and coated with some silver or other ions, and they have been used for the purification of water. Now, how the nanotechnology plays an important role in the purification of water or treating the wastewater. The creation of functional material. What is nanotechnology? In brief, everyone now nanotechnology, nanomaterial. I will not go into the details of the nanotechnology, but only in few slides, I'll just say what is nanotechnology. The creation of functional materials, devices, and systems through a control of matter on the nanometer scale length, that is in between 1 to 100 nanometer, and exploitation of novel phenomena and properties, physical, chemical, biological, at the length scale. So what is nanotechnology? It is nothing but the creation of functional material, new materials, devices, systems through a control of matter at nanometer length scale. So it works at nanometer scale, that is 1 to 100 nanometer, and these materials, these nanomaterials exhibit novel properties or novel phenomena, and there we found that there is an increase in the physical, chemical, biological, and properties of this nanomaterial. The development of nanoscience and nanotechnology shows their potential in removing toxic elements from water bodies with better water treatment. So this nanotechnology, we have technology to remove the toxic element which are present in the wastewater. Nanomaterials belongs to the size range of 1 to 100 nanometer, exhibiting unique properties as compared to the bulk material, leads to the enormous improvements in many sectors, including health, manufacturing, electronics, environmental remediation as well. So the nanomaterials, which belongs to 1 to 100 nanometer size, are useful for various issues, various fields, that is health, manufacturing, electronics, and for the wastewater treatment also. The various techniques in water treatment can categorize into the following 6 classes: adsorption, biotechnology, catalytic process, membrane process, ionizing radiation process, magnetically assisted process. There are large number of techniques available for water treatment of safe drinking, that is adsorption, solvent extraction, precipitation, reverse osmosis, evaporation, membrane separation, and photocatalysis. So these are the techniques available for the water technology. We are concentrating only on the photocatalysis technique for the wastewater treatment. There are specific advantage as well as disadvantage for a particular water purification system. So every system or every method has some drawback and some advantage. So similarly for this technique also there are some advantages and some disadvantages also. We will not go into the details of the advantage and disadvantage. This is the mechanism of removing pollutant from the wastewater, that is nanoadsorption, nanofiltration, and photocatalysis. This is the 3 ways for removing the pollutant from the wastewater. You can see here in this slide, we all cover all these techniques or the processes: the adsorption, membrane, catalysis, then adsorbent, how the contaminated water get purified through these various techniques. This is nano adsorption. Nanoparticles have larger surface area. You all know that it exhibits a smaller size but larger surface area. The surface to volume ratio is very high for the nanomaterial or nanoparticle. It can be used in reactive groups to increase their chemical affinity towards target compound. Activated carbon is the widely used adsorbent in conventional method. Higher efficiency with the use of CNTs and metal-based nano absorbent. Then this is a nanofiltration technique. It is a, I'll just briefly show. Nanofiltration is a pressure-driven membrane separation process falls between ultrafiltration and reverse osmosis. Low pressure membrane process. Nanofiltration membrane has pore size 1 to 5 nanometer. Higher flux rate allows the transition of monovalent ions, but multivalent ions are largely retained. So this has drawbacks or limitation. Nanofiltration have been shown to remove turbidity, microorganism, nitrates, and arsenic from groundwater. For example, carbon nanotubes and nanoceramic filters are used for nanofiltration. We are concentrating on the photocatalysis activity or the photocatalysis process for the removing the pollutants from the wastewater. It is advanced oxidation process. Major barriers for its wide application is slow. The spinel ferrite nanoparticles are largely used in the coming days for the wastewater treatment. Low dimensional semiconductor material like TiO2, ZNO are also used for this purpose. With well-controlled morphology, sizes, and surface properties have attracted great attention to the field of photocatalysis. So these nanoparticles or spinel ferrite have the smaller size, the larger surface area, and superior property, magnetic property that have attracted the scientists for use them in wastewater treatment. Steps involved in the degradation of organic compound, the external diffusion of reactant to photocatalysis surface. This is the first step. Then adsorption of contaminant. The contaminant present in the water get adsorbed. The reaction of adsorbed organic compound with photoexcited photocatalysis. I'll show in detail. Desorption of reaction products, mass transfer of reaction product to build bulk water. You can see here pictorially it is try to explain how the photocatalysis wastewater taken in a beaker, then it is exposed to the sunlight or any ultraviolet light, and after photocatalysis reaction, the clean we get a within 40 to 60 minutes of clean water. So this is very simple and best technique for the removal of contaminant or the pollutant from the wastewater. This is the mechanism, how it works. You can see here various dyes are the industrial area, particularly the cloth industries. They throw the various dyes, rhodium rhodium bit, RSB and others, so that can be treated. Advantages over the other conventional method for this photocatalysis: it is the efficient method, it is reliable method, it has a high capacity, it is a regenerative, recyclable, and moreover, it is stable compared to the all other method. So photocatalysis is one of the best techniques for use in removing the pollutant from the wastewater. The magnetic nanometer, so we have seen that the magnetic nanoparticles are for the removing the pollutant from the wastewater. So these magnetic materials have been potentially used for the removal of water pollutant, particularly organic contaminant, dyes, chlorinated hydrocarbons, aromatic, pesticides, as well as heavy metals. Heavy metals like chromium, lead, like that, which have been deposited in the water. The magnetic nanoparticle may be paramagnetic or ferromagnetic or super paramagnetic with tailored surface have already explained their scope for application in water treatment. These magnetic nanoparticles, as I mentioned that, have very peculiar property, that is the smaller size in between 1 to 100, mostly it is between 1 to 20 nanometer. Then it exhibit larger surface area. Then some of the magnetic nanoparticles show super paramagnetism, that is the coercivity is very less. Then they are mostly stable, and being a magnetic in nature, they can be removed easily and they are recyclable. Therefore, these magnetic nanomaterials are currently used for the photocatalysis and removing the waste pollutant from the wastewater. There has been increasing magnetic materials in water treatment, which are basically composed of magnetic cores of iron oxide, organic compound, carbon materials. Recently, nanomaterials in different shape morphologies forms, example, metal containing nanoparticle, carbon shares nanomaterial, zeolites, dendrites, carbon nanotubes, nanofiber have been used for the water purification. These are the kinds of the nanomaterial. These materials are used for the separation of solid material from liquid, and which is more difficult as the particle size decreases in nanoscale. So these materials are used for the separation of solid materials from liquid, and which is more difficult as the particle size decreases to nanoscale, because these nanomaterials are at having size 1 to 100 nanometer. On the other hand, using the magnetic particles like magnetic nanoparticle or MNPs or spinel materials have the advantage of magnetic filtration in separation of solid from liquid and are more efficient. So this is more advantages for using the magnetic nanoparticle. These are the advantages of using magnetic nanoparticle as an adsorbent. Small surface to volume ratio. Solid liquid separation through the magnetic filtration is selective. It is possible to separate out the nanomaterials because they are magnetic. Faster than centrifugation and filtration technique. We can use it number of times there, that is reusability, and mostly they are biocompatible, that is the main advantage. Then we can have the magnetic separation by external magnet. We can remove them from the solution or from the water. Different types of magnetic materials have been synthesized and designed for the development of advanced materials and applied effectively in widespread uses such as biomedicine, magnetic resonance imaging, catalysis, spintronics, robotics, engineering, environmental remediation, etc. So these nanoparticles have advantages or effective or have the application in various fields. Biomedicine, in the last my lecture, I have explained how the magnetic nanoparticles are used for hyperthermia treatment. Now magnetic resonance, it is somewhat related to the hyperthermia. The catalytic, which we are also working, spintronics, material robotonics, and other applications. These magnetic materials are made from the mixture of iron and the divalent metal ions like cobalt, nickel, and their alloys. So in general, it is defined as MF2O4, where M is a divalent metal like copper, nickel, like that. In addition to their suitable magnetic properties, ferrimagnetic, the synthesis procedure is simpler and cost effective, and they can be easily functionalized as designed for many applications. So why we should use the magnetic nanoparticle for the removing of the toxic element? It is because that they exhibit a very good magnetic properties, like that is ferrimagnetism, ferromagnetism, super paramagnetism at nanoscale. Secondly, the synthesis procedure is very simple. One can do the experiment or one can prepare this magnetic nanoparticle at laboratory level also. And third is it is cost effective. Very no expenditure takes place, or when short you can have a small equipments are used for the making this magnetic nanoparticle. Large number of like wet chemical precipitation, then spray drying, other spray pyrolysis, and so many methods are there on which we are working. And all these methods are very easy, simple, and cost effective. So synthesis procedure is very simple and cost effective, and moreover, they can be functionalized. These nanoparticles can be functionalized for a desired application. We can functionalize, or we can coat them with some iron or like that, silica or other particles, and we can functionalize them to apply them for particular application. So these are the some important properties of this magnetic particle, and therefore they have been used for the removing of the pollutant from the wastewater. The size and shape and magnetism of this magnetic can be easily be controlled. The further advantage of this magnetic nanoparticle is that their size and shape and magnetism can be controlled. We can control the size, shape, morphology, and the magnetic properties by adding some suitable dopant or by choosing selective method for preparing them. So we can control, we have control over their different shape, size, and property, and for particular application. Thus, they can be easily dispersed in liquid medium, and their stability can be retained for multiple uses. So we can easily disperse these particles in a water, and their stability is very good. They can be retained for multiple uses. So we can use them for number of uses. For if you use take a 100 ml of water, and again it is treated, again we can use the same nanomaterial for treating that. So in that way, it is for multiple uses we can use it. Moreover, these materials are non-toxic, or I'll say it is less toxic, because cobalt ferrite is little bit toxic, chemically inert and thermally stable and biocompatible. So you will look all the properties or all the characteristics of the magnetic nanoparticle are very beneficial for treating the wastewater. This is working of the photocatalysis. I will show by taking the, when you see here, when photocatalysis material absorbs UV radiation from sunlight or illuminated light source, it will produce pair of electrons and holes. The electrons of the valence bands of material become excited when illuminated by light. So you see that how photocatalysis works. So the contaminated water or pollutant is exposed to the ultraviolet light or sunlight, and thereby there is the creation of electrons and holes. The excess energy of this excited electron promotes the electron to the conduction band of material, therefore creating the negative electron and positive hole pair. So there is a formation of pair electron and hole and pair. This stage is referred as the semiconductor's photoexcitation stage. The energy difference between the valence band and the conduction band is known as the band gap. So the important for the magnetic nanoparticle is their band gap. So if there is a greater band gap, then they are more effectively used for the treatment of wastewater. The positive hole of material breaks apart the water molecule to form hydrogen gas and the negative electron reacts with the oxygen molecule to form superoxide ion. This cycle continues when light is available. Overall mechanism of photocatalytic reaction. So in this way, photocatalytic reaction takes place. The maximization photocatalytic activity is based on the following point. The rate of decomposition of the pollution is based on these factors: absorption of electromagnetic radiation and band gap of semiconductor. So band gap is one of the important parameters for the material which is using for the wastewater treatment. The rate of recombination of excited electrons and holes is important. Surface property of the semiconducting material is important. Absorption of reactant through the nanoparticle, intensity of incident electromagnetic radiation, temperature of the pollutant, pre-absorption of oxygen. So these are the factors on which the photocatalytic reaction is based. The ferrites or the spinel ferrite, though they are not the semiconductor, but they behave as a semiconductor because they have the high electrical resistivity and therefore they can be used. The semiconductors like TiO2, ZNO are traditionally used for the water purification, but recently these magnetic nanoparticles are also used for this degradation of the pollutant. Features of the good photocatalysis: it should be inert in nature, it should be non-toxic, and it should be liberated toxic products in environment. It should be activated by the application of light. It should be cost effective. It should be user friendly. Synthesis and fabrication. One semiconducting material among number of alternative is nickel ferrite. Now we'll come to our actual experiment and our results and what is the conclusion of our experimentation. So all these properties or all these features, the important features for a good photocatalysis are associated with the spinel ferrite nanoparticle, that is nickel ferrite. We have chosen the nickel ferrite for our study. Now this is the basic definition of the ferrite. Most of the participants who have gathered here or listening this my talk, they belong to the ferrite. That is, so I'll not go into the detail, but for those newcomers, those who don't know this area, I'll briefly introduce the ferrite. Ferrite is nothing but the iron oxide and metal oxide. That is the combination of Fe2O3 and metal oxide, that is cobalt, nickel, like that. The types of the ferrites are the spinel ferrite, garnets, and hexaferrite. So according to the crystal structure, they have been classified as spinel ferrite, garnet, and hexagonal ferrite. This is the crystal structure exhibited by the spinel ferrite. It has a two-side tetrahedral A and octahedral B side. I will not go into the crystal structure of the because it is not our aim. Characteristics. What is the characteristics of this nickel ferrite spinel? It is magnetic conductor. You see that beauty of this ferrite material is that it has a capability of conducting the magnetic properties. It has at the same time, it acts as the electrical insulator. So both the properties, that is the magnetic conductor and electrical insulator, both are present in a ferrite material, and that is why ferrite is a very good material. It is a multifunctional material and can be used for a large number of applications. We have seen the bulk materials and the nanomaterials are also playing important role in various applications. Magnetic conductor, it behaves like semiconductor. I have mentioned that it is not a semiconductor, but it is behaves like a semiconductor because of it has a high electrical resistivity. As I mentioned, it has both electrical and magnetic properties, and it has a large number of applications. Moreover, they can be prepared very easily. They are chemically stable and low cost material. So these are the advantages of this magnetic nanoparticle, in particularly the ferrite nanoparticle. Now, the nickel ferrite, which is chosen for our study, is have a particular feature which are helpful for the photocatalytic reaction. The band gap, the large band gap is here 2.8 electron volt, nearly for that of the TiO2 or ZNO. The surface area is very high, that is about 55.25 meters square per gram. Compared to other semiconductor, it has a favorable feature to be used for photocatalysis. Photocatalytic activity is enhanced by doping with transition metal and hybridizing. So we can enhance the photocatalytic property by adding some suitable dopant in the nickel ferrite matrix. Now, how the nickel ferrite is prepared? It is prepared by various techniques, the soldier autocombustion technique, the ceramic technique, the hydrothermal technique, microemulsion technique, synthesis. All these techniques we are working in our laboratory. We are using them in an efficient way to produce the magnetic nanoparticles. So for the preparation of nickel ferrite, we have chosen sol gel method. It is a very simple method and used by number of researchers to produce the nanoparticles of the size 1 to 100 nanometer. So all of you know the detailed steps involved in the sol gel method. It requires some nitrate and some fuel as a chelating agent to start this reaction. So this is the steps involved in the preparation of sol gel. I will not go into the details. Only I'll say that we have prepared the nickel ferrite magnetic nanoparticle using the sol gel autocombustion technique. And once the material is prepared, it must be characterized by some of the important techniques like X-ray diffraction, scanning electron microscopy, magnetic properties, ultraviolet spectrum, absorption studies, TGA-DT, and optical properties. So all these characterizations have been taken on the nickel ferrite nanoparticle from a institute. This is the XRD pattern for the nickel zinc ferrite. We have some dopant in the matrix of the spinel ferrite, then the properties of the photocatalytic are increased. So this is the X-ray diffraction pattern of the nickel zinc ferrite, varying composition of X0 to 0.1. So you'll see that this XRD pattern is very clear and it does not show any impurity phases. Thus it is a single phase and all the reflections belongs to the cubic spinel structure. So this is a cubic spinel structure. The intensity and broadening is little bit broadening is there. It is because indicating the nanoparticle nature. So X-ray diffraction pattern proves that the material prepared, that is nickel ferrite, is of single phase and possesses a cubic spinel structure. This is a thermogravimetric and DTA, that is the thermal studies. When once the material is prepared, it is to be subjected to the thermal studies in order to know the ferritization temperature. So through this study, we have sintered the materials at around 500 to 550 range for a few hours using muffle furnace. So this is the structural parameter. We will not go into the detail. This is how the lattice constant varies with the zinc concentration. Scanning electron microscopy technique used for the characterization of the material to know the surface area to volume ratio is more, and also for grain size. The morphology, to study the morphology, whether agglomeration takes place, whether there is a formation of spherical grains or flower-like structure or rod-like structure. All that can be studied through this scanning electron microscope. So through this, we obtain the grain size and specific surface area, which is very high to and is enough for the photocatalytic purpose. This is a time. Another characterization to know the particle size, very important. We all say that nanomaterial should have the size between 1 to 100 nanometer, but how to find out the size, particle size? It is through the TEM, we find out the particle size and we prove that it is in between 1 to 100 nanometer. So this is another right side diagram shows the particle size distribution. And more importantly, these are the magnetic in nature. So we must study the magnetization properties of this material using VSM or pulse field hysteresis loop technique. So this is a pulse field technique which is available in our lab to measure the various magnetic properties such as saturation magnetization, coercivity, then remanence ratio, and all other derived parameters or magnetic parameter through this pulse hysteresis technique. You will see that this is a MH loop and it shows a very less coercivity. So it becomes a supermagnetic in nature. Then we have studied the UV visible properties or optical properties, because these nanomaterials should be exposed, or the pollutant should be exposed to the sunlight. So UV visible studies are takes place to know the band gap of the nanoparticle. So this is the first graph, and this is the how the band gap is increases with the nickel concentration is shown. Now this is the absorption rate. You can see here for various time for 0 minute, 20 minute, 40 minute, 60 minute slot, we have studied this absorption of these nanoparticles and how it is degraded, the particle it is shown through this ultraviolet study. So the graph you will see here, the for methylene blue, we have seen that various dyes are coming out from the industrial waste, particularly from the clothing industry. So we have taken methylene blue as a dye instead of rhodium B, on which number of reports are available. So methylene blue is taken for our study as a dye, and the wastewater is of the methylene blue. So how it is used, that is shown here. You can see the peak goes on diminishing with the increasing time, right? This is a band gap. How the band gap of nickel ferrite is obtained? It is 2.81 electron volt. So using ultraviolet study, UV visible study, we obtain the band gap, and it is more important for this photocatalytic purpose. And we found or obtained a very good or very higher band gap of the order of 2.81 electron volt. So I'll show how the degradation takes place by the photographs which were taken. 1 minute. You will see here, the diagram clearly shows how we get a clear water through this nickel ferrite nanoparticle. In 0 minute, we in blue, and the wastewater is there in first flash. After 20 minutes, the color of this wastewater is changes. It becomes a little bit blue in nature. After again 20 minutes, it slightly the color is decreased and it becomes a faint blue. After 60 minutes, you will see that the color of the wastewater is completely changed and it becomes a white crystal clear water, and so it proves that it remove all the pollutant, that is methylene blue is degraded by the nickel ferrite nanoparticle. So in this way, the photocatalytic action takes place, and our material, that is nickel ferrite nanoparticle, is effectively used for the degradation of methylene blue dye from the wastewater. So this is a important observation recorded in our laboratory, and you will see that what we need only beaker and some stirrer and like that. So these are the simple equipment which are available to everyone, those who are really interested in research. Lastly, the conclusion of our study. So nickel ferrite with zinc as a dopant concentration, and for various composition of zinc, we have studied the photocatalytic activity for the degradation of methylene blue. So the magnetic nanoparticles are nickel ferrite are useful for photocatalytic reaction and found good candidate for the wastewater treatment. So our study concluded that using the magnetic nanoparticles of nickel ferrite, one can lead to the degradation of the various dyes which are present in the wastewater, and you will require a very small amount of the magnetic nanoparticle. This magnetic nanoparticle can be prepared in a simple way. It has a large number of property. They can be usable they can be separable from the water. And so because of all the important properties or the characteristics of the magnetic nanoparticles, they are effectively used for the degradation of this methylene blue dye. So our study proves that methylene blue get degraded by using nickel ferrite magnetic nanoparticle. I would like to acknowledge or thanks research students who have helped me in preparing this slide. Dr. Anil Raut, who has taken a lot of effort in preparing this slide. Then Ashok Kumbe, Dr. Ashok Kumbe, the Swapnil Jadhav. Swapnil Jadhav is my student. He is working on the photocatalytic. So the experimental data was of his research. Then Sandeep Saumanshi, he is working on the biomedical properties or application of the magnetic nanoparticle. And another student, Mr. Gopale. So I am really thankful to my student who always help me in making these slides. Thank you to one and all. Thank you. Hello. Hello.
Thank you, sir. Thank you. Dr. Jadhav, sir, please continue.
Okay, sir. Hello. Are you getting me, sir?
Hello.
Hello.
Yes, sir, please continue.
Yes. Thank you, sir. And at my personal level. Hello. Hello. Thank you, sir, on behalf of the college at my personal level for your excellent, informative, and impactful talk on the magnetic particles for wastewater treatment. He focused how the nanoparticles, magnetic particles, can be used in the water purification and in lightening the nanoparticles, nanotechnology with their novel properties. Your lecture will be fruitful to the new research workers, new research scholars, and students. Friends, I would like to acknowledge that the today's web conference is organized due to his constant inspiration, guidance, persuasions. For this, I am thankful to him on behalf of the college and also at personal level. Thank you once again, sir. Hope your blessings and guidance will be helpful us in the future also. Thank you a lot, sir. Now the session is open. I request Dr. Ganjewar, sir, to continue. Dr. Ganjewar,
Thank you, sir. Thank you, sir. Thank you. Now, friends, all dear participants, this session is open for questionnaire. I request dear participants to ask question to Professor K.M. Jadhav, sir. Any question from dear participants? If anybody is interested to ask a question to Professor K.M. Jadhav, sir, please feel free. Please ask question. Dear participants, any question is there to Professor K.M. Jadhav, sir? Please ask.
Sir, there is one question from YouTube.
Okay, please. Gadi sir, please ask the question.
Does the technique is cost effective? In Sali has asked this question.
Hello.
Yes, sir.
Can you repeat the question?
Does the technique is cost effective? Nitin Sali.
Yeah. Making? Hello.
Sir.
Hello.
Sir,
Hello.
does the
method
sir, repeat the question?
Does the technique is cost effective?
Yeah. The technique, that is the preparation of the magnetic nanoparticle, is very, very cost effective. As you will see that it can be available, or it can be easily can be made available with the low equipment. What we need is the magnetic stirrer, we need some beakers, we need some pH meter. All these equipment which are needed for the synthesis of the magnetic nanoparticle are very, very cheaper as compared to the very sophisticated instrument, and that's why the method is cost effective. Further, the chemicals which we require for the synthesis or the raw materials are of the air grade, and they are also not so costly as compared to the other. If we take the, in comparison, the high TC superconductor, if you want to prepare a Y123 compound, that is the first superconductor which of the material of the 99.99%, and in the cost of the chemical is that for 1 gram it almost costs about 20,000. So in comparison to all such a material, if we see the cost of the raw material used for the synthesis of magnetic nanomaterial is very, very less, and one can afford personally also, I will say one can afford the price personally also, and that's why the method is always said to be, it is a cost effective. Yes,
Thank you, sir.
you get it?
Is there any other question on behalf of the participants to Professor K.M. Jadhav, sir?
Phone.
If any other question is there, please ask. Dr. Gade, sir, any question is there on YouTube? No.
No, sir, there is no question.
Okay. So shall we wind up this session? Thank you, sir. Thank you, Professor Dr. K.M. Jadhav, sir, for your excellent presentation and keynote address.
Thank you. Thank you.
Thank you, sir, once again. Now I turn up to the convener, Professor Dr. L.V. Jadhav, sir, for the introduction of the first invite, Dr. N. Rohila. Dr. L.V. Jadhav, sir.
Thank you, sir. Friends, for first technical session, we have Honorable Professor Dr. N. Rohila, sir. I would like to warm welcome Honorable Dr. Rohila, sir, for gracing the event with his presence. He is well known, popular due to his research work. He is an eminent scientist. He gave his contribution in developing the several laboratories. Dr. Rohila, sir, had been working over a period of 38 years as a scientific officer in Bhabha Atomic Research Center. His research and development career spans the complete period in various projects associated with setting up the primary standards laboratory for determination of absolute activity of radionuclides. He has developed a low-level counting system for monitoring radioactive contamination on materials used in various applications. Further, he worked on development of gas flow proportional counters and established 4 pi beta and 4 pi beta gamma coincidence counting systems for calibration of radionuclides decaying by beta and beta gamma emission. His contribution in development of primary standards brought this laboratory recognition as a secondary standards laboratory by IAEA and WHO. In addition, he established several secondary standards such as ion chamber, scintillation gamma spectrometer, and GILI HPGE multi-channel analyzer for photon emitting radionuclides, surface barrier detector for alpha and end window GM counter setup for beta particles. He has participated in several international intercomparison programs of activity measurements organized by SIR UK BPM, France, and ETL, Japan. He has organized about 10 national intercomparison of I-131 activity measurement in hospitals and radiotherapy centers. During his studies on standardization of radionuclides and beta gamma, he developed a special interest in basic research relating to radiation interaction with matter. Very soon, he impressed national and international experts in this field through exchange of ideas and number of papers published in leading journals. His doctoral work examined further into basic phenomena of beta particles and gamma radiation. He has established empirical relations between range energy and atomic number of pure elements and composite materials, in addition to large data on attenuation and absorption coefficient as required for radiation shielding and domestic measurements for pure elements and compound materials. Apart from R&D work, he has associated with calibration of X-ray and high-intensity teletherapy sources, radiation monitoring instruments, and secondary standards dosimeters. As a co-coordinator of education and training programs associated in a teaching program of various courses conducted by Health, Safety, and Environment Group and Training School, BARC. He was an active member of several professional bodies and have organized many conferences, public awareness programs, short and long-term courses. As a reference, he has reviewed several scientific papers and PhD theses and conducted viva voce of several candidates. He is an active principal collaborator of several scientific projects sponsored by broad research and in nuclear sciences. He has his credit more than 120 scientific and technical papers published in national and international journals of repute. With his brief biodata, I request Honorable Dr. Rohila Mathuram sir to give his invited talk on the role of radioactive nanoparticles in healthcare. Honorable Dr. and Rohila sir. Hello. Hello, sir.
Sir,
Hello, sir.
yourself.
Hello, sir. Hello, sir. Are you getting me, sir? Rohila, sir. Power, sir. Hello, sir. Hello, sir. Are you getting me, Rohila, sir? Hello, sir. Please unmute yourself, sir. Please, sir. Hello, Rohila, sir. Please unmute, sir, yourself, sir.
Dr. Rohila sir, please unmute yourself. Your voice is not getting.
मी बोलले तो गेले तिथपर्यंत.
How about now? Are you able to hear me, please?
Yes, sir. Now I am getting you also.
Okay. So thank you very much for introducing me to the audience. And I feel pleasure in joining you in this web conference, which is organized by the Marathwada section Sarak Mandal. So it's my prime duty first to convey my sincere thanks to the principal, Dr. Rinath, to vice principal, to Dr. Jagade, to Mr. Guy, vice principal, and the convener, Mr. Jadhavar, Dr. Jadhavar, and the coordinator, Dr. Ganjevar, and also Dr. Desai. It's a pleasure for me also to convey my sincere thanks and best wishes to the patrons of this college, all the patrons, the college development committee members, and also the organizing committee members. So, as you have already introduced me to the audience as regards to my work is concerned, I had been closely associated with Dr. Yadav for the last 25-30 years, and to the Aurangabad Physics Department for more than 40 years. It's my pleasure today to be on the to join this particular conference on the subjects, that is nanoparticle technology, about the developments. Mr. Jadhav had been working in this field for a very long time, and he had on his credit a good number of publications, a good number of students who had joined him from different universities, and it was also my pleasure all the time to interact with all the students and whatever their problems and whatever the instrumentation requirements and whatever the discussions they need to have on the subjects. We had provided the necessary materials and instrumentations. So as a part of the grants from the BRC, from the Bhabha Atomic Research Center, as a principal collaborator, I could fund this Department of Physics for a very long durations. And I'm happy to say that the physics department, I could establish a nuclear science laboratories where all research activities can be carried on, and students can get benefited for their postgraduate PhD programs and other activities. So with this, today my presentation is on the subject that is related with the nanoparticles. Nanoparticles means as far as radioactive substances are concerned, how these radioactive nanoparticles are being used in the medical sector, in the health sector, and how these particles are able to serve the society, particularly in the field of medical imaging. So let me just start with the presentations and the So this is the role of radioactive nanoparticles in medical imaging. Why medical imaging? Only I have selected the subjects because as a head of the radiation standard sections, I was associated with radioactive substances, their development, their preparations, and their usage as far as the nuclear medicine departments are concerned. And we were carrying out all around the calibrations of the measuring instruments, monitoring instruments, and also taking the safety aspects of all the users as against the radiation hazards which is associated with radioactive substances. So with these few words, I'm going to start with the presentations. So in the radiation standard sections, I could establish most of the equipments as briefed during my introductions, and we have given the services to all the research institutes, to the universities, and also the hospitals as regards to any kind of the source calibrations, source requirement, and also necessary training. And I could invite good number of students in my laboratory for their PhD and postgraduate studies. So today presentation is radioactive nanoparticles in medical imaging. As you know, the radioactive nanoparticles are almost similar to the normal particles, except they are radioactive. Except they are radioactive means they emit certain kind of radiations. The type of the radiations and how this kind of the radiation, this type of radiation is useful in medical imaging. I have outlined my presentation as far as the radioactive introduction is concerned, nanoparticle classification is concerned, community used, radiopharmaceutical, commonly used, how radioisotopes are produced, and what are the various imaging modalities which are being prevailing in the diagnostic and radiology and nuclear medicine centers, and also some of the non-invasive imaging technique which doesn't require any kind of radioactive substances. So, as all of you are quite aware, the discovery of was accidentally done by Becquerel in 1897 while studying the effect of sunlight on a ore that is pitch blended. Normally it's a uranium matter minerals. So what it was expected that when it is exposed to light, it may emit some fluorescent materials. So during this experiment, he could find that the imaging plate, which was totally covered with a black paper, means he ensured that no light will come to this one, reach to the photographic plate, and even after that, he could notice that the photographic plate became dark. And that was some kind of the radiation which was getting emanated from the pitch blende. So further experiments demonstrated that a mixture of charged particles and electromagnetic radiations were being emitted for the effect on photographic film. So he joined this Madame Curie, and also the other physicist, that is to study the radioactive material, particularly pitch blende, which was more radioactive than the uranium extracted from it. So it was a uranium that from there they were extracting the radioactive materials. So deduced 1898 the obvious explanation that pitch blende must contain traces of some unknown radioactive component that was more radioactive than uranium. So the study was initially taken up for extracting the uranium, but they could find out that there are radiations are coming out from the pitch blende, and that was the beginning of the discovery of radioactivity. And soon after the discovery, they were started using it for various other research associated with this, that is purification of the pitch blende. The first, they named pitch blende as a polonium after Mary's native country, Poland, and the other they named radium, that is from the intense radioactivity. So radium was the material, the radioactive material, which in its pure form emits alpha particles, beta particles, and the gamma radiations. So these radioactive nanoparticles are the nanoparticles of radioactive material which are emitted during radioactive decay. See that one of the important characteristic of this radioactive material is that it emits radiations, and the intensity of this radiation goes on decreasing with respect to the time. So there exists a radioactive decay in the nature and also processed artificially in a nuclear reactor. So normally some of these radioactive materials, they are present in the nature, and other radioactive materials can be processed in nuclear reactors. I would like to tell that in our BRC, the Bhabha Atomic Research Center, there are more than 10 to 11 nuclear reactors, and in countries as a nuclear power plant, there exist more than 15 nuclear reactors. And in these nuclear reactors, they are using for the production of the electricity, but production of radioisotopes also is a bypass, that is a secondary products. So radioactive nanoparticles have wide application in the field of medical diagnostic, medical imaging, toxic kinetics, environmental health, and also being investigated for many more applications related to the nuclear nanomedicines. So they are not only used for the research purpose, but also they find extensive use as regards to diagnosis, as regard to diagnosis of the certain ailments is concerned, as regard to the therapeutic use of the other ailments is concerned. So these particles are classified mostly in the three categories. You have the medium size, you have the mean size, and you have the mode size. These are the particle sizes, but they are all below 100 nanometers. The size of the particle is always below 100 nanometers. That is the scale which is being taken there, and it can be compared. What exactly, why we call as a nanometers or nanotechnology? A sheet of paper of about 100,000 nanometers. A strand of human DNA is about 2.5, and there are 25 billion 4 lakhs nanometers in 1 inch This is the scale which we are getting it. A human hair is approximately 80,000 to 100,000 nanometer wide. A gold atom is about a third of a nanometer in diameter. So these are the scale. If the diameter of a marble was 1 nanometer, then diameter of the earth would be about 1 meter. 1 nanometer is about as long as your fingernail grows in 1 second. The growth of fingernail in 1 second is a measure of around 1 nanometer. So how small one can think of the nanometer size. These are some of the examples, how the nanometers have been defined about the DNA, about the bacteria, about the large raindrop, about the single wall carbon nanotube, the hair, the house, and nanoparticle, the ion. So many examples you can see that, because we can see these small insects, we can see the bigger insects. So how small one can identify and what will be the size of these particles. And you can make a comparison. 1 nanometer almost work out to be around 10 to power minus 8 of a meter, and piece of paper, as I have already told you, it is 100,000, and gold atom is around 0.3 nanometer. One can think of or look for the comparison as regard to the universe is concerned. These are some of the sources from where one can get aerosol colloids, constituents of the soil, and sediments as a part of the nanoparticles which are present in the nature. This present scale of the nanoscale, that how the how the various objects or various products, like that of protons, centroids, polymers, etc., they can be scaled, you can say. So radioactive nanoparticle, they are most commonly used as radioactive nanoparticle in the PET-CT scans. Currently is to diagnose potential oncology conditions. So in hospitals, in our society, you will find that quite a good number of patients, there exists a large number of patients who are suffering from various kinds of disease, and one of the methodology which is utilized to potentially diagnose the oncology condition, that is by using the PET scan. PET stands for positron emitting tomography, and it is combined with a computed tomographic equipments. The reason that both PET and CT scans are performed is because the PET scan is needed to perform functional and as well as the anatomical imaging. In this kind of the equipment, you will find that our nanoparticles in various stages, how they are being used as regard to obtaining the image is concerned, as far as injecting the nanoparticle of radioactive substance is concerned to the patient, and then quantifying the amount of the radiations which are associated with this, then discovery or making a camera or a sensor or a detectors which can detect the kind of the radiations and give a precise diagnosis of the ailment. There is a very advanced tool as regard to diagnosis is concerned. So these nanoparticles of radioactive materials, they can be used for the virus detections, can be used for cancer detection, can be used as a carbon nanotubes, gold nanoparticles, nanodots, then nano wires in the form, and they can also be utilized as a gene detectors. Cancer is the main subject for which I have prepared this particular presentation, and how the CT scan works on the nuclear medicine, that I am going to explain in details. So carbon nanotubes and silicon nanowires are being used for detection of the cancer. So gold nanoparticles and nanodots, similar applications. Antibodies attached to nanoparticle antibodies bind to the cancer cells. Color reflected when light hits particles, and shape and size that also affect the color. What is the shape and the size? Similarly, for the gene detections, can detect specific genes, nucleic acids attached to the wires, specific sequence can be created, and sensor capable of differentiating mutated and non-mutated genes, and PCR, that is needed detection of the time lowered. That is, and in conventional radiology, that is imaging techniques, you have the other methodology, that is one can make use of the X-ray, one can make use of the MRI, that is magnetic resonance imaging, fluoroscopy, and CAT scan. This scan will provide you with the images, and through the images you are able to diagnose what kind of the ailment the patient is having it. But they have certain limited details different to track movement. So they can also be utilized for molecular tracking. They are using the quantum dots as the labels. The dots attached to the molecules between, before the injection. Fluoroscopy used to track movement, and color from dots. So one can see that these are the imaging applications. That is, the proteins are tag protein of cells with gold nanoparticles. We process of angiogenesis, important for cancer detection and imaging. So these are some of the methods which are being utilized for detection of the several kind of the ailments. So these nuclear radiations, which we talk most of the times, and sometimes the people are scared of these nuclear radiations, but they are certainly very useful from the diagnosis part, from the treatment part, and they can easily be synthesized as a radiopharmacy and can widely be used in medical imaging and diagnostic applications. As you know that the nuclear radiations means from the radioactive materials, an atom can liberate alpha particles during radioactive decay, can give rise to the beta particles, also emit neutrons, and also the gamma rays when it is come from excited state to the ground state. So 4 type of radiations are quite popular, are quite significant as far as the radio imaging is concerned. One can see here, apart from the beta particles, we have the beta particles. The beta particles normally carry a negative charge, but there is a opposite particles which is known as a positron. So positron carries a positive charge. It has some properties very specific to medical imaging. It is very specific to medical imaging, which I'm going to discuss here, I will give you the details of all these things. Now you can see these are the isotopes normally prepared in the BRC, that is a Bioatomic Research Center, and they are very useful. That is, we normally, I have listed the isotopes, and they are the specification, that is the first rubidium, galenium, carbon, you have technetium, you have iodine, strontium, and krypton. These are some of the isotopes which are processed in a nuclear reactor, as also sometimes some of the isotopes, they are accelerator product. So that is particle accelerators. So particle accelerator exists. The one is like that of Indore, that is a CAT, Center for Advanced Technology, cyclotron at Calcutta, and another two cyclotron Bangalore as well as at Delhi. So many more have come there. So by using of these things, we are able to get the required radiopharmaceutical products, that is from the extracted radionuclides. From the extracted radionuclides. So two main diagnostic radioisotopes, which are very widely for more than 95% of the diagnosis we are making use of it. That is for the PET. PET stand for positron emitting tomography. As I told you earlier, you can see these isotopes give rise to two gamma photons, which can be detected by the two detectors which are placed simultaneously. And it has the affinity to bound with the cells which are present in a particular tissue or particular organ. So one can use this particular technique for diagnosis of particular organ. So this is the system, and it is known as the PET scanner, positron emitting tomography, in which the patient is, after having injected this radioactive materials, he is being scanned for the particular organ. So, and the scan mechanism, we will brief you. I will detail you a little later. As I told you, the radioactive substances are injected, and two radiations which are generated as a result of the absorption of the positrons, that is the gamma radiation, can be viewed by the two gamma cameras, and they can give very precise, very accurate location of a disease cell or disease organ. You can see here, this is the kind of the scan one can obtain, that is a whole body scan using technetium-99. That is one of the isotopes which is best suited for this. Now these are the pharmacy which BRC, that is Radiopharmaceutical Division, exists there, and it is there in New Bombay, and it produces a number of pharmaceuticals which are supplied to the users. Users means they are either the diagnostic centers or they are the hospitals which are present in our country. And there is a strong requirement. There means the requirement of these isotopes is quite high, and we try, or BRC try its best to provide most of these isotopes. The isotopes which are not available or which cannot be processed in a short time are being procured from other countries, and they are processed in BRC laboratories, and thereafter it is supplied. So what we are doing there, the normal radiopharmacy is labeled with these radioactive materials. Normal pharmacy, just like a glucose, is labeled with the radioactive fluorine 18. So this fluorine 18 is one of the nanoparticles which are required to be attached to molecules of the glucose, as it is seen here. So this is a 2-fluoro 2-decay deoxy D-glucose that is known as the FDG. FDG is a short form and it refers to the 2-fluoro 2-deoxy glucose, and how the structure is gets modified. So this is just getting attached to the glucose, that is the molecules. In the similar fashion, there are many more commonly used radiopharmaceutical. One of the such pharmaceutical is technetium 99, that is M, and this is used for nuclear medicine produced in the nuclear reactors. This is a reactor product. The primary radionuclide used for therapeutic nuclear medicines procedure is iodine-131. This is another isotope that also is produced in the nuclear reactor. So technetium-99, that is for the brain, for the lung scanning. Mostly it is used when we go for the thyroid scanning. So radiopharmaceutical generators are there. So sometimes the pharmacy or the radioisotope attached as a tracer is having very short half-life. So by the time it is produced in BRC and transported to the place where it is going to be used is a time consuming. So as a result, some of the generators, the hospital or diagnostic centers, they have their own. So they procure a long-lived isotopes, that is molybdenum-99, and they extract the short-lived isotopes, that is technetium-99M, which has got only 6 hours as the half-life. So they need not be dependent on the BRC, but they can procure and they can process at their own laboratory. The importance of generators lies in the fact that they are easily transportable and can serve as source of short-lived radionuclides in institutions located in remote areas. So in places like Bombay, when BRC is there, it can go over time. But if it has to be airlifted to other places and then transported by road, it may take more time, and by the time it is there, its activity will go down. So these are some of the isotopes. They are very specific use. They emit photon energy, which is around 140 keV, and can be made use in the scanning of, can be used as a SPECT, that is single photon emitting tomography, SPECTs. So you can say these are the kits, technetium-99M kits. They are labeled radiopharmaceutical, are usually produced by simply adding technetium tetraoxide to many choices of cold kits. So these are the kits which carries this technetium-99M and which can directly be used for injecting to the patients. So this is the sequence of the procedures. So you see, he takes necessary precautions. He has a gloves in his hand, a syringe in his hand. He draws the radioactive materials and transfer in the other vial, and then mix with the other radiopharmaceutical or carry out the dilution as required. Thereafter, it is injected to the patient, and then the patient is scanned for the scanner. So the iodine is produced in a nuclear reactor, is used in diagnostic uh, applications, procedures involve the thyroid and also for the treatment of the thyroid disorder. So you can see this is a thyroid uptake, means the patient is asked to take this iodine 131. It will get distributed in the body. Maximum it will go to the thyroid, and thereafter and can be administered in capsule also. It can be taken shown here, but it can also be in the form of the capsule. Nowadays, we prefer to provide this iodine 131 in the form of capsule, so that like other medicine, like other pharmacy, and this will be absorbed in the body and get deposited in the thyroid. So one need to take necessary precautions as regard to the radiologist or the technicians or the doctor is concerned, that no spill should be there. And these are some of the generators which are installed in the hospital itself. One can easily prepare the radioactive pharmacy required for the PET scan. So there is a small cyclotron and there is an industrial cyclotron, means you can produce more amount of the fluorine 18, that is FDG. So these isotopes are, as used in nuclear medicines, are produced in the, you can see these two are the very old reactors and are also in use even today. So most of the radioisotopes which are required for the imaging purposes are being obtained during nuclear fission year, and they are subsequently processed in the hot lab, which is shown here. You can see a person, a technician, is handling these radioisotopes in a closed container which is lined with the thick lead valve as well as thick lead glass and manipulators. He need not to make use of his hands directly, as he will get exposed. So this artificial hands maneuver is being provided there. And above the pictures, one can see a big, at the end here is the radiochemistry lab, radioisotope laboratories, which process the radioisotope which are obtained from the nuclear reactor. And here is a big laboratories known as the modular laboratories, which house the various research activities, most of the science streams. So these nuclear munitions, as you can see here, the person is having the protective lead gloves. The sources are contained in a lead containers. Otherwise, if it is not contained in the lead container, his hand will be exposed to radiations and it can cause some kind of biological damage. So to avoid those biological damage, he is provided with a very sealed container. The radiation should not come out. These are the lead lining. You can see here. So when you stand here, you don't get any kind of exposure from the radiation which are being emitted constantly by these sources. So this is a technetium 99 and the main work force of nuclear medicine. So technetium 99 M usage is dominant as a nuclear medicine, and it is used for the brain scan taken by the technetium 99, one can see a number of the sequence of the images, and from which a radiologist will be able to identify the cold spots, and thereby the necessary treatment can be extended to the patients. So once the isotopes are used by the or taken by the patient, how the isotope is distributed in the body or in the particular organ is done. It is done by a nuclear medicine, that is by a Anger camera. So Anger camera came after its inventor, that is Hall O. Anger, in 1958 came out with a scintillation camera, and he established the basic design so that the radioactive distributions in the patient can be monitored. These are the kind of the sequence that the radiations are being emitted here from the patients. They pass through the collimators. One can see the small collimators here. Then there is a sodium crystal, thin layer of sodium crystal. It's a material which, on exposure to nuclear radiation, there is the gammas, it will emit the light, fluorescent light. These fluorescent light falls on the photocathode of this photomultiplier. You can see the small tubes here. So there are a number of tubes. There will be 100, 500, and even thousands tubes will be there, depending on the size of the camera. These tubes, they convert the signal or which is produced at the photocathode. The first element of this tube is a photocathode. What exactly happens? The gamma produces the light, means the gamma photon energy is converted into light by the sodium crystal. These lights falls on the photocathode of these photomultiplier tubes and get converted into the electronic signals. These electronic signals are position sensitive, and they get multiplied by a series of diodes which are part of each of these photomultiplier. As a result, we get the signal here. The signal is converted into or amplified for analyzing. Position sensitive, you have an intensity sensitive. You have the signal, what is the intensity, and then you have the signal from where it is coming there. As a result, when you combine all these data, it will result in a particular scan which is shown in the right side of this particular slide. So it can have 3D image formations, that is, and one can look at, these are the spatial resolution, that is difference on source to collimation. So how these images look like, the one which is at 5 centimeter, 10 centimeter, 15, 25 and 30 means at a distance. So it is a distance sensitive. So means whatever the signal you are getting here, it should be as close as possible to the patient, but there is a certain limitation, and one have to look at what distance you get the appropriate image. So the image type which you can get, one can obtain a static image. You can see the scan here. So here is the radiopharmacy is fixed over the imaging period. Here you can see the whole body scan. This is a partly, that is like that of the thyroid you want to have look at. This is the entire bone scan, the complete body scan using the technetium 99. And then here is the You can then the dynamic or the functional imaging also one can have from the positron emitting tomographic scanner, that is PET. So you can obtain a static image, you can get a whole body image, and you can also have a dynamic image also. You can see the function of the heart muscle can be manipulated using this particular camera. So this is the typical scan showing the heart muscles. So one can judge it, or one can think of how good or how strong your heart is. These are the static scan, which we had. This is the normal thyroid scan. You can see the thyroid, that is a normal scan, and nodes that is on the right, one can see at this place. So this is the normal and this is the code. So in this case, what exactly happened there? The cyclotron, the recent maintenance acceptance, the positron emitting tomography. Now here, before that, I have just shown you about the one single camera only, that how the radiation emitted by the patient can be monitored. That is the one type of radiation, need not be positron. But for positron emitting radionuclides, that is like a brain tumor and all kind of things, they want to go very precisely as far as location is concerned, as far as its volume is concerned, its mass is concerned, everything is obtained when you go with the positron emission tomography, that is a PET. So these are the, this is a particular system. This is the PET scan. It looks like a normal CT, that is computed tomography, and it can be used for the brain functions, for the cancer, for the detector must have the specification, relatively expensive. It's a quite expensive system which need to have. So radiochemistry, that is better tracer, imaging physics, better images by detector design. It has a very good spatial resolution, sensitivity, and image processing, corrections for physical effects, image reconstructions, so data analysis, biological monitoring, etc. So all these things can be done there. You can see the how the radioisotopes is injected to the patients. Thereafter, it goes to the brain and gets accumulated here wherever the any tumor or any disnormality is there. So after it gets deposited here, it emits two radiations. These two radiations are simultaneously detected by two detectors. Detectors which are placed in opposite direction. They are mounted on a ring. They are mounted on a ring here so that the patient can be positioned correctly. So this is synthesizer radio tracer we are using as, that is a radioactive material, that is FDG, inject, then measure gamma ray emission from isotope, that is 20 to 60 minutes. The time taken is around 20 to 60 minutes, and the data which you collected, you can reconstruct the image distribution in terms of the nanocurie per unit volume, that is cc, cubic centimeter, and this is the image constructed. This image can be compared with the normal brain scan to find out any kind of dismoralities. As I told you, FDG, the one of the bond is labeled with fluorine 16. Fluorine 16 is a radionuclides which emits positrons. These positrons, they get converted into two annihilation gamma radiation, one going in this direction, other going in the other directions. So you can see the fluorine atom as such, it has the nucleus, it has the neutron, protons, and then it emits electrons. So these electrons are having positive charge. Normally electrons are having negative charge, but in some of the radioactive substances, these electrons are emitted with positive charge and they get immediately converted into two gamma photons, which are detected simultaneously. So they decay with a beta plus. You can see here, you are having the positron and you have the antineutrino. So antineutrino we are not concerned, but positron, because antineutron has a very short life, so it gets immediately absorbed. But this positron gets absorbed in the body and thereafter it emits two radiations which are emitted in the opposite direction, and these radiations are having fixed energy of 511 keV. So one can easily use these two energies to localize the position of the tumor in the brain. So you can see here, you have the 511 and these are the detector circle. So any side this 511 goes, it will get detected by these radiations. So that is the advantage. It will not escape without getting detected. So its efficiency is very high. Of interval means the emission, that is 1 nanosecond, means it's a fast counting. One can make use of it. You can see here, you can get that is XY. So at various angles, these are trajectories. You can trace it here, how the radiations are passing through the brain, are being emitted from the brain. Here in this case, the patient becomes radioactive, the radiation comes out from the patient. Whereas in other modalities, you will find that we are passing the radiation from outside. So this by using the back projection, you can manipulate the image here. So this is the kind of the image one get it here. And these are the important properties of the detector, which normally we make use of it. And these are the kind of the scans which normally we obtain from the PET. And of course, the sensitivity or the type of the detector which we are using and how fast is the response are detectors. Because the detector is slow one, you can't carry out this kind of scanning. So we need to have a very fast detector. Once the signal is detected or the radiation is detected, it has to be processed by the measuring system. That is known as the picture archiving and communication. So that also has to be very associated. And these are the properties which I normally say that we want a material. So when radiation falls on that, it doesn't get scattered, but it gets absorbed in that one. So only after the absorption we get the necessary signal. Otherwise we don't get it. So scatter and attenuation is the main criteria. There should not be any reflection from the detector. So mostly we make use of the sodium iodide or sometimes beryllium oxide, and many more detectors are available. So this is the sequence, that is the prototype, that is the detector which I have shown that it is a scintillating material. That is gamma photon converts to proportional to the gamma energy, that is about 1000s. That is the number of photons per photons emitted or per keV, let us say. These are the scintillations are viewed by a photomultiplier tube which collect at the end of the crystal, and these signals are modified by using preamplifier electronics. So these are the three main characteristics of the detector system, that once you get the signal, then it can be processed to reconstruct the image. So these are the subject of the current developments, detectors, what should be multimodality imaging, specialized applications. But I don't want to go in details of all these things because of the time limitations. So here, this is one of the system which I have already told, but there are many more systems existing. The investigations or diagnosis which you want to do it with non-invasive medical imaging techniques. If you don't get it here, then you can get it from the PET scanning, which I have just explained to all of you, which I have just explained. So these can be used for getting the anatomical images and also can be used for the getting the functional imaging. You can have the normal X-rays, conventional radiography, you can computer aided tomography, you have the MRI, that is magnetic resonance imaging, you have the ultrasound, and you can get the image of our body, that is anatomical image. You can procure, you can construct it, and if you want to see the functioning, you can make use of the nuclear medicine as discussed. And there are two types of camera. One is a SPECT camera, or the second one is the PET. And there is a one which is coming is a optical fluorescence phenomena, but that is not very popular. So I will not list out. So here I will try to list out some of the radiographic equipments which are already in the hospitals, like a conventional radiography, where chest X-rays and other lumbar spine, brain, etc., everything can be taken up. So normal X-ray equipments. This is the X-ray equipments which are used for the dental, that is known as the intraoral dental equipments, to see how the teeth is growing. And this is the how the this is known as the mammography, that is to check the growth of any kind of so that is a cancer detections. And then here is the CT scan, that computed tomography. You can obtain the image in the form of the slices, and thereafter you can convert it into the 3D imaging. And here you can of the OPG. Normally it is referred as a orthopentography, or the head, entire jaw you can have the image. And here during the surgery, one use a fluoroscopic C-arms equipments to see how the progress of the surgery is going on. And these are the kind of the image. You normally, these are having the X-ray as the main source of the radiations. These X-rays are filtered to get a appropriate energy of the X-ray. Then they are projected, passed through the patient, and then to the DAS, that is data acquisition system. Then this is projection. We take their projection, and thereafter we are getting the reconstructions, that is hardware. And finally we come to a image, that is get it here. So that this CT image is from the X-ray, but here you can have the different slices. You can mark the what is the volume, what is the length, breadth, and the height of the area of the patient you want to scan it here. And there is another equipment which is based on not X-rays but on magnetic waves. This is this doesn't have any kind of radiation risk, but all other equipments which are listed here, they have the associated X-ray radiations, that the risk of this one. Here it is a magnetic waves, and these magnetic waves are used to get a image of the tissues which are normally soft in nature, but cannot be distinguished by using CT or by using any other method, can be investigated or can be diagnosed using magnetic resonance imaging, MRI. This is the kind of the equipments. Now, since it is a magnetic equipment, means there exists a strong superconducting magnets. It has the potential at any ferromagnetic substances, as in this case. So we should not carry anything made out of the ferromagnetic substances in the room where MRI machine is installed. Otherwise, it leads to a traffic accidents. So this is the kind of the precautions one need to have it here. And then for gynecological investigations, we mostly go with a ultrasound or for a newborn child where the tissues are very soft. You can see here you have a ultrasound equipments, and these ultrasound equipments you can use it for scanning the unborn child. And here you can see the results which you can get it from the ultrasound scanner. You can see the different conditions, that is how the child is growing and the kind of the function. So it is a kind of functional imaging using the ultrasound. So these are the mostly the imaging techniques, imaging modalities, which are of our hospitals, particularly super specialist hospitals, and you can get the detailed information about the unborn child, fetus information, but there is a control by the government, that is PNDT Act, not to reveal the informations, but as such the radiologist can know all about it. So with this, I come to the end of this presentation, and I hope that every one of you or must have liked it. This is part of the work which we had been doing it, and we are taking care of most of the diagnostic centers in keeping these equipments updated, providing necessary safety guidelines, and providing the any updates upon this. So with this, I come to an end, and I wish to thanks the organizing committee, all members. I wish to thanks college development committee, and also the our patrons, and particularly the principal and my colleague, Professor Dr. K.M. Yadav, who has inspired me to give this particular talk at this occasion. Thank you very much to all of you.
Thank you, sir, for your kind, graceful, present, and delivering remarkable, notable, innovative talk on the role of radioactive nanomaterials in the health care. He focused how nanoparticles can be used for cancer treatment and for the thyroid. For that purpose, I am thankful to him on behalf of the college and at a personal level. Thank you, sir. Now the session is open for the discussion. I request to Dr. Ganjewar, sir, to continue.
Thank you, sir. Thank you for inviting me for the questionnaire session. May I now request the participants to ask a question to Professor Dr. Androila. Is there any question, Professor Gade, sir, as regards this session?
Yes, sir. There is one question from you.
Please continue.
Sharma want to ask, explain new nanomaterial synthesis method.
Pardon?
Explain new nanomaterial synthesis methods.
New nanomaterials. That is development of the radioisotopes. I can, if you provide me your mail, I can provide you with a list of the radioisotopes, which apart from the list which I have explained, which I in one of the slide, I can give to you.
There is another question, sir, from
Yes.
why we have used new innovative materials.
Why we have
Use innovative nanomaterials.
actually, if you look at the size of the particles, like protons, like positons, electrons, etc., they are much smaller than these nanoparticles. But when we are processing it, the substance in which they are tagged, so their size also increases. So that's why we always refer them as a nanoparticles, and material as such cannot be used unless until it is converted or it is in the size which can easily be absorbed by a particular tissue or particular organ of the body of the patients. So here, whatever the instrumentation, whatever the systems which we have developed, and how I have prepared these isotopes also, because the process is very long, which I cannot explain in this presentation, but certainly it is a time consuming and require very sophisticated instrumentations, sophisticated methodology, a chemistry, which I have just shown only a glimpse of this laboratory in one of the slides. I hope that you understood.
Yes, sir, sure. There is no any other questions, sir. Dr. Ganjavar, sir, please carry on. Ganjavar, sir, please unmute yourself.
Pardon?
Thank you for this nice presentation in this questionnaires. Without making any more delay, may I take your permission, sir, to turn to Dr. L.B. Zadwar, sir, for the introduction of Dr. Vikas Patil, sir. Here is a request from the committee that the resource persons are requested to give their presentation within 20 to 25 minutes, please, hereafter. So, Dr.
Okay.
Zadwar, sir, please give the introduction of Dr. Vikas Patil, sir.
Okay, thank you, sir.
I'll do
Dr.
that.
Zadwar, sir.
Yes.
Thank you, sir.
Thanks very much.
Friends, for the next technical session, we have Honorable Professor Dr. Vikas Patil, sir. He is Professor and Head, Department of Physics, Punyashlok Ahilya Devi, Holkar, Solapur University, Solapur, and Director, IQAC. He is Chairman and Board of Deans of Solapur University. He is the membership of Management Council member to Holkar Solapur University, Academic Council member, BOS Chairman of Nano-Technology, BOS member in Physics, Applied Electronics, SGM College, and member Senate SUS. Again, he is the member of Research Recognition Committee of Physics of Solapur University, Solapur, and member of BUTR Science, Solapur University Science, RUSA coordinator, Solapur University, Solapur. The sir has a teaching and research experience more than 23 years. The area of his area of research is polymer-based hybrid gas sensors, solar cells, and supercapacitors. The sir has published the papers in international and national journals. Nearly he published 174 papers. The sir has given guidance for the PhD degree. He have guided nearly 12 students, and 5 students are working presently.
Eh?
The H index is nearly
Oh,
44. The citation is 4,898. I-10 index is 150.
वो पीछे का चल रहा होगा, मेरा हो
Total
गया.
impact factor is 422. The research projects
ना window close
for
कर दिया.
DST, the two BRNS, one CSI and two UGC, and one is of RUSA. The grant received for project is more than 1 crore. The sir has published the 7 books. The 11 book chapters are published and he has visited abroad like Paris, France, Jeju, South Korea. The sir has given the lot of invited talks in international and national journals. The sir has delivered in the lectures in international conferences is nearly 24 and in national conference is nearly 17. The sir has awarded and fellowship of fellow Maharashtra Academy of Sciences in 2016, Young Scientist Award of DST in 2009, Best Teacher Award of Solapur University, Solapur in 2018, and Gunwant Shikshak Award in Lok Mangal Foundation, Solapur. Prajnavan Puraskar, the Swatantraveer Dada Udankar Samiti, Undale, Taluka Karad, District Satara. The sir has received the 2 patents on flexible ammonia sensors and NO2 gas sensors. The sir has the good and excellent biodata. Now I request Dr. Vikas Patil sir to deliver his talk. Dr. Vikas Patil sir.
Okay, Namaskar. Thank you, Dr. Jadwar sir, for kind introduction. At the outset, let me thank convener of the national webinar, Dr. Jadwar sir, Principal Dr. Sirsat sir, Vice Principal Dr. Jyodesh sir, Dr. Gaikwad sir, co-convener of this webinar, Dr. Desai sir, and whole organizing team for giving me an opportunity to participate in this national webinar on recent developments in material science and nanotechnology. I congratulate Dr. Jadwar sir and his team for organizing such a webinar in this pandemics. It is indeed a great pleasure for me to express my views on current approaches to be undertaken globally to suppress the effect of COVID-19 pandemic. I am going to in this webinar on enabled approaches of nanotechnology against pandemic COVID-19. During my talk, I will explore how nanotechnology emerging as well as I will explore current trends of research development and innovation in India as well as the abroad to fight against COVID-19, and which basically material emerges, the nanomaterials basically emerges for fighting COVID-19. The today's update of India as a COVID-19 pandemic, there is more than 12 lakhs people, basically they are infected in India. Therefore, the present situation is critical, and to fight this, nanotechnology will play a vital role in this pandemic. Coronavirus infection disease that is usually called as COVID-19, which is started in late 2019 and has already infected the numbers of people in the globe and lead to serious deaths. This pandemic this number is still rising quickly. The COVID-19 the pressing need of countries, including India, to focus as STI in both policy as well as the practical terms. The virus drive the leaders to ensure the technology and innovation, which translate directly into the daily lives of the people all over the world. And basically, so just see, this is the present scenario of the infected peoples in India. That is more than 12 lakhs people they are infected by the pandemic COVID-19. So what is the basic structure of this virus, that is COVID-19? It is called as a SARS-CoV. That is basically the picture shows the structural model of a coronavirus particle, showing the nucleocapsid coil. That is, it is a green color. Inside an envelope, it is a brown color with protein spikes. That is proteins. The protein spikes are there. Okay, and they are marked as the red in the picture, and in the and segment of the nanocapsid. This is a basic one structure of the COVID-19. Now, this slide shows the attack on the respiratory system. Basically, the COVID-19 or the SARS virus, it attacks the respiratory system. Typical components of this particular virus is the lead and respiratory fluid droplets, which is basically it is a droplet actually. As it shrinks during the evaporation from the man, all compounds are connected, concentrated basically, and it has proteins and debris as well as various liposomal compounds are there, and these basically are the soluble molecules mass called, and whole it is called as the nuclei. The common transmission pathway of the COVID-19. That is, it started with the infected person releasing viral lead and respiratory fluid droplets with close proximity with this infected person. That is, could be infected by directly inhaling airborne contacts and the formants. It is also called as a dried nuclear by receiving a virus through the contact transfer. Basically, indirect fomite infection occurs when viral laden nuclears are picked up from the contaminated surfaces. That is, main source is the hand, and then delivered to the mouth, nose, or the eyes. Okay, there are many approaches to set up several layers of defense barriers are there. In this slide, it is shown by A, B, C, D, E, and F, along with the infections pathways to remove or to deactivate viron before they reach the next person. So these are the transmission pathways of the COVID-19. Just see, that is the main source is the sneeze or cough by infected person, then the infected droplets, and these infected droplets get on your hand, and when it is transmitted, when you shake the hand or when you can touch the any surface or person, so the virus is transmitted. So this is the common transmission way. Then a second way to transfer this COVID-19 to the person, that is sneezing, coughing by infected person. That is infected droplet, and infected droplet get on your hand and virus is transferred on the man. So basically these are the present common transmission pathways of the COVID-19. Now just see this slide. These are the various approaches basically enabled by the nanotechnology. The COVID-19 outbreak has fueled a global demand for effective diagnosis and treatment, as well as the mitigation of the spread of infection. All through very large scale approaches are needed, and these large scale approaches basically they will find alternative antiviral methods and classical disinfection protocols. No doubt, due to there are abundance of the various engineering materials, and these engineering by their user physicochemical properties through the versatile chemical functionalizations. And no doubt, nanotechnology offers a number of approaches to cope with this emergency. Basically, there are multidisciplinary approaches are there. For example, the virology is there, biology is there, medicine is there, engineering there, chemistry, material science, and communication. Basically, these multidisciplinary approaches basically useful to fight the COVID-19. Now, how the nanotechnology-based strategies can support to fight this COVID-19 pandemic, or as well as the another SARI-like diseases are there, are called as infectious diseases are there. Basically, considering what we know so far about the cycles of the virus, maybe COVID-19 or we envision key steps where nanotechnology surely could counter the disease. Then first approach, it is a nanoparticles. Basically, the different nanoparticles, they offer basically various alternative methods to the classical disinfections protocols used in the healthcare settings. And thanks to the intrinsic antipathogenic properties of the nanomaterials or their ability to inactive that the TiO2 is one best material. Basically, it is used in the mass production of the mass. Basically, it inactivates the virus, bacteria, fungi, as well as the various photothermal. How it kills or how it inactive this. Basically, there are various methods are there. So by using photocatalytic method or the process. So basically, this is the use of the nanometals. Then basically, nanotechnology tools, many tools are there. In due course, I will show you. It is also called as the SARS-CoV-2, that is SARS-CoV-2, that is SARS-CoV-2 in patient could be explored. In this case, basically, nanomaterial could be used to deliver the drug. Basically, already the research, various large research done on the delivery of the drug through the nanomaterials, that is cadmium sulfide, cadmium selenide, zinc oxide, such kind of the basically nanomaterials used for the delivery of the drug. And in the particular pandemic, you have to deliver drug to the pulmonary system to inhibit the interaction between the COVID receptors and the virus. In addition to the disease, basically, not only inactivate the virus or bacteria or fungi, but it prevent the disease as well as the therapeutic potentials. Therefore, nanotechnology has an important role in diagnostic with potential support the development of simple, fast, and cost-effective nanotechnology-based test. Now, you know that the one test is the antigen test is there. So it is within a fraction of time, you can get the information of you are get infected by the COVID-19. So this is asset of the nanotechnology. That is, and the nanotechnology is critical in when preparing for slides how basically the COVID-19 body. Basically integrating the nanomaterials into personal protective equipment. Basically the nanomaterials, they are used in the PPE. Okay. And can be, it prevent basically the PPE, it prevent the entrance of the COVID in the respiratory systems. Maybe the mask is there, maybe the apron is there, or maybe the gown is there. So these are the personal protective equipment. Materials could also be used to deliver drug to the pulmonary system via inhalers. Then the cellular bindings of viral particles at the alveoli can be inhibited using the targeted nanoparticles like TiO2 or CDS. Then various mechanisms can be used to activate viral particles such as using neutralizing nanoparticles or photocatalytic nano materials. Nanomaterial based vaccines or immunomodulation can be used to prevent the COVID-19 infections or even to boost the immune response during the infection. Now, the various tools to fight the COVID against 19. Basically, the nanomaterials based vaccine developed for the immunomodulation and the dynamic inactivation of SARS-CoV-2 they will use to fight the COVID-19. and there is biomimetic engineering of nano system. One can use for the purpose.
बोलू का मी? हॅलो हॅलो पाटील सर. हॅलो पाटील सर. ह्याच्या बोलू का? असं आहे का? कॉल करू का? हॅलो. इथंच आवाज आहे. हॅलो पाटील सर. Hello, sir. Are you getting me, sir? Hello. Mute करू का?
I think Dr. Vikas Patil sir has lost his connection. Patil sir, are you there?
चला कॉल करू का?
यादवर सर करा ना, फोन करा ना.
हॅलो गाडे सर. सरांना फोन लाव.
हो मॅडम.
Now screen is shared, sir.
Yes, sir, it is visible.
Yes.
Oh,
Yes.
okay. Now, sorry for disturbance. Maybe this is due to the internet connection. Emerging standard for the fight of the COVID-19. So just see the slide. The graphene and the transition metal oxides, dichalcogeners basically, they are used for to fight the COVID-19 as used. And the various metal oxides and the metals, those having the antibacterial properties, basically they are used, or basically these are emerging nanoparticles used for fighting the COVID-19. Which are these? Zinc oxide, titanium oxide, and copper oxide. And the metals, nanometals like the titanium, tungsten, and the zinc oxide, basically they were used for the preparation or the fabrication of the nano tools to fight the this is the science and technology and innovation efforts in India. So these are the polymer swabs for testing COVID-19. Covering basically, you see the polymer swab. It is prepared by the CIMET Pune, and the polymer swabs that is covering the acute shortage of the testing acutes. These polymer swabs basically they are consisting of polymer rods or sticks and polymer fibers with locally sourced material. The basically the polymer rod, it is developed with thermoplastic polypropylene material through injection molding, and these polymer fibers are then crimped pressed on the polymer rods. So this is the one tool, nanotechnology based tool developed by the CIMET Pune to fight the COVID-19. Now the antibacterial and antiviral masks again developed by the CIMET Pune. So basically this antibacterial masks, they are based upon the metal as well as the metal semiconductor nanoparticles. Generally doped metal oxides, that is AU or AG dopants basically used. Okay, they are having very good antibacterial properties. AG zinc oxide, copper zinc oxide. Basically, why these materials? Basically, these are cost-effective alternatives for the N95 masks in India. Presently, we are using N95 masks. So N95 masks, so it protects from the virus. It not kills the virus, but with the help of the AG zinc oxide or copper zinc oxide or the AuTiO2, like nanomaterials, you can kill the viruses. So they will not enter into your nose. So basically, these are the advent of the nanotechnology, basically. Then the plasmonic, another nanotechnology based device is available to fight the COVID-19. It is a plasmonic portable sensor for COVID-19 virus antigen in blood. So basically, it is based upon the disposable. It is a sensor. Basically, it is a sensor. It is based upon the semiconductor metal like the polymers or the zinc oxide or SO2 based sensor basically used in the plasmonic portable sensor, and basically it detects the chip inside. It detects the antibody present in the COVID-19 and it present in the blood. And after functionation of the sensor, efficiency analysis on the designed bioreceptors with a different patterning stains. So with the help of this portable device, you can get extremely useful for the random testing of the patient at a very low cost. So this is another way to fight the COVID-19 with the help of the nanotechnology tool. Now, just see the science and technology and innovation efforts in India. So it is based upon the field effect transistor biosensor. Here main material is the graphene. Now graphene, irrespective of the metals as well as the metal oxides or doped metal oxides, graphene is emerging material used as a sensor material basically, and it is selected nowadays to fight the SARS-CoV-2 basically it not protects from the COVID, but you know that I already shown the various the viral structure of this COVID-19. It has some spikes, protein spikes, and these protein spikes basically these spikes basically they are removed or destroyed with the help of the antibody. It is conjugated in the graphene sheet. Okay, so basically so such kind of the tools basically used to fight against the COVID-19. Now the efforts at our laboratory basically. So at functional materials laboratory, we have developed a zinc oxide nanorod, WW nanorods, TiO2 nanorods, by very simple nano approaches, by using chemical bar deposition, by using the hydrothermal method. So these are very low cost methods. Basically, the TiO2, zinc oxide, WO3. So these are basically used for suppressing the both virus as well as the bacterial infections. And these nanometals emerging the best doped the zinc oxide, that is pure these materials, that is the metals as well as the metal oxide by AG, AU and the copper. And basically they are cost effective alternatives for the N95 mask and used for the in future for the PP kit. Basically it not only protect but it kills or it destroy the bacteria including the viral species and their parasites also. Means it kills bacteria as well as their parasites also, and it controls a lot outbreak of COVID-19 via early stage home treatment. That is biosensors are there. So biosensors are developed with the help of the zinc oxide, tungsten oxide or the SNO2, and such kind of the work we have done at our functional material research laboratory. Okay, so it is displayed on the slide, and it lower the risk of the infection. So these are the basically tools nowadays used for the protection of the COVID-19. Now the various efforts basically they are undergo in India to fight this COVID-19. The Sri Chitra Tirumali Institute of Medical Sciences Technology Tirunelvelim has developed a diagnostic kit, and presently we are using this kit. Basically with the help of this we can confirm the COVID-19 in 2 hours at a very low cost. This is the Indian innovation. Another, the Raman Research Institute, that is RRI Chennai, they have analyzed the importance of mathematical models. Basically, they have developed more mathematical models, and that are being used by scientists for the prediction of the COVID-19 pandemic, for planning the future actions and relevance of these models for the common public. Rajiv Gandhi Center for Biotechnology, that is RGCB Tirunelvelim, is the first. It is in the final stage of developing a kit that promises to help detect SARS-CoV-19 infections as early as 4 days post-infection of this virus. You know that present period it is a 7 to 14 days, but so the to detect the SARS-CoV-19 infection before the 4 days. The Center for Materials for Electronics Technology, CIMET Pune, as well as the Pune University, as well as the Mumbai University, they have developed already the polymer straps as well as the personal protection equipment. And our functional materials laboratory also developed the protective masks based upon the TiO2 and doped TiO2. Science and technology efforts in the abroad. Basically in the abroad there is many institutes. They are basically developing the tools to fight the COVID-19, that is rapid point of care diagnostics. Then the vaccine development. Now you have heard about the that is vaccine development. It is in the last stage. The Serum Institute, they have developed with the Oxford University. So maybe they told that it will come in the market soon. Then basically different therapeutic efforts basically they are going on. Then surveillance and monitoring efforts also presently doing on to fight the COVID-19. Concluding remarks, nanotechnology is not only inspired by the virology to develop the novel tools, but also at the forefront in combating the dangerous virus. That is, we say that COVID-19 setting the seed for nanotechnology. Then nanotechnology tool to inactive SARS-CoV-2 in patients. Basically, the nano used as a promising tools for immunomodulation, either stimulating or suppressing the immune response. That is called as biomimetic engineering of nano delivery systems. They are developed. That is, the nano biosensors are valuable alternative to conventional laboratory equipments for clinical and environmental analysis. Then nano tool to detect the SARS-CoV-2. That is SARS-CoV-2 inactivation by the nano-based tool. That is, for example, you can use the copper brushes or copper containing alloy rather than stainless steel, because you know that copper is antibacterial property, so that you can use this for the to provide effective antimicrobial surfaces, like you know that the doorknobs, then bed rails, like that. And in the healthcare settings, you can use these materials. Nano-based solution to increase the efficiency and solution to the protection devices. In the pandemic COVID-19, there are many approaches for nano-based solutions to increase the efficiency and safety of air filter. That the TiO2 we have developed, then polymer straps, they are developed by the CIMET group, and finally the emerging nanometals for the fight of the COVID-19. That is basically graphene is now the emerging metal basically used in the present scenario or in the pandemic. Last but not least, being the researcher, it is our prime duty to fight against it by all the means that we can do. You can do research and innovation in that field. We cannot sit back and keep watching. Thank you very much. Be safe at your home. Thank you very much. Hello. Thank you.
Hello, sir.
Hello. Thank you.
Thank you, sir.
Thank you.
Thank you for your informative, excellent, remarkable, notable, and excellent talk on an immediate approaches of nanotechnology, COVID-19 pandemic. I hope this talk guidance will be helpful in the career and research work of these participants and will enhance, upgrade their knowledge, information, and interest in the research. According to me, sir, I humbly would like to point out that Dr. Vikas Patil sir is a open-hearted and big-minded and broad-thinking. Friends, I would like to point out that you might comes to know that the sir has the strong biodata and he is constantly engaged in the research work, and apart from this he has the good administrative experiment. He has worked as in charge of vice chancellor and in charge of registrar in the Solapur University, Solapur. Now the session is open for discussion. I request Dr. Ganjawar sir to continue.
Thank you, sir. Thank you, Dr. Jadwar, sir. Friends, now the session of Dr. Vikas Patil, sir, is open for questionnaire. I request the participants to ask questions to Dr. Vikas Patil, sir. Dr. Gade, sir, is there any question on YouTube?
No, sir, there is no any question.
I request all the present participants to ask questions, sir. Dr. Vidhate, sir, is there any question?
Hello, Ganjawar sir.
Yes, sir.
I have one question.
Okay, please ask, sir.
Patil sir.
Okay, please continue.
Have you prepared any material in your lab regarding this COVID-19?
Yeah, we have prepared the TiO2 zinc oxide materials as well as doped silver and gold nanoparticle based. And we have fabricated based upon the TiO2, and we have tested actually this proposal to the for the funding for that.
Thank you, sir.
Is there any question from the participant side? We are waiting for the questions from participant side. Is there any question? Dr. Shivanand Shirsagar sir? Dr. Dindore sir, is there any question? Okay, thank you, Dr. Vikas Patil sir, for your presentation. Thank you once again, sir. So
Okay,
now,
sir, okay.
yes,
Sir, at the end, I wish to thank convener Dr. Jadwar sir, principal research sir, and whole organizing team for giving me an opportunity to present my views on basically the enabled approach of the nanotechnology in the present scenario of the COVID-19. Thank you very much. Thank you to all.
thank you, sir.
Thank you.
Thank you, thank you. Thank
May
you
I
from the
leave now?
bottom of the heart.
Thank you very much.
Now I turn up to Dr. Kirti Desai, co-convener of the webinar, for the introduction of the next resource person, Professor Dr. Vimal Gandhi. Dr. Kirti Desai, ma'am.
Yes, sir. Thank you, sir. Now, last session start for. Good afternoon to one and all. Myself, Dr. Kirti Desai, MSP Mandals of Arts, Commerce, Science College, Dharur. I introduce to detail for biodata Dr. Vimal Gandhi, sir. Associate Professor, Department of Chemical Engineering, Dharma Singh Desai University, Nadiad in Gujarat of India. Sir is presently working as Associate Department of Chemical Engineering, Dharma Singh Desai University since last 20 years. Sir received his PhD in the area of applications of nanotechnology in environmental engineering from Dharma Singh Desai University in 2011. Sir serving as an independent director of BEL Infrastructure Limited and Enviro Technology Limited in Ankleshwar. And next, in the field of research and consultancy, Sir has guided several graduates and undergraduate students for their project work, and Sir has more than 20 publications, presentations in international, national reputed journals and conferences to his credit. Sir edited one book on photocatalytic nanomaterials for environmental applications published by Material Research USA. His current interests are in the field of environmental engineering and synthesis of nanomaterials. Sir also organized various training programs for chemical industries in Gujarat, including of PI industries. And in today's online webinar, he will brief us about quantum of generations of waste water in the world and India. What are the challenges in the conventional wastewater treatment techniques and need of advanced treatment techniques along with main focus on heterogeneous catalysts. He will also share his research experience in the field of heterogeneous photocatalysis, and also he will talk about photocatalytic nanomaterial synthesis, characterization and applications for removal organic compounds. And thank you, sir, and welcome, sir, for this to be continue this session. Hello, sir. Hello.
Professor Vimal Gandhi sir, please continue your presentation.
Hello, sir.
Sir, please unmute yourself and start your session.
Hello, sir. Hello.
Yes, sir.
Sir, can you hear me?
Yes, sir.
Yes, sir. Please continue.
Sir, I am facing one problem at just now of connectivity. Can you hear me, sir? Please reciprocate. Hello.
Yes, sir. Carry on, sir.
Yes, sir. Please continue. Continue, sir. No
Yes, sir.
problem. Continue.
Just, sir, bear with me for 2 minutes. I will join. Just 2 minutes. Bear with me because I am facing problem here on my side. So please, sir, I request you to bear with me for at least 1 or 2 minutes.
Okay, sir. Okay.
Please, sir. Just a minute, huh?
Okay, sir.
Just a minute. Uh, Thank you very much. So, and I'm apologize for delayed of 2-3 minutes because of problem at my side connectivity issue. Is it visible, sir?
Yes, sir. Yes, sir.
Can I continue?
Yes, sir.
Okay. Uh, Thank you very much, madam, for your introduction, and I'm also very much thankful to Patil sir for at least make you aware about metal oxide nanoparticles, particularly TiO2 and DOP TiO2 nanoparticles. And I will mainly focus on these 2 points in my presentation. So before we go ahead, I am under impression that we have mass of students also. So I incorporated some of the slides for students' viewpoint for understand this subject in better way. But as I shown in the participants list, I found that majority of the participants are either doctorate or having good research experience. So I don't want to take your much time because of delayed in the program on introductory part, but I will mainly focus on how you synthesize nano materials, photocatalytic nano materials in the lab, and then how you characterize that material, and finally you use that nano materials for industrial application. So that related to photocatalytic nanomaterials. So initially I put certain slides, but I will quickly go through that slide and then we go ahead for case study kind of thing that we, hello, is it okay? Please,
Yes, sir. Yes, sir.
okay, okay. So we go ahead. So in my presentation, mainly I cover introduction and about nanostructure material in first 15-20 minutes time, and then 30 minutes time on case study of nanomaterial that we synthesize in our laboratory and successfully apply that material in certain technologies. And we publish a good number of articles also on these nanomaterials. So before we go into detail of that, I congratulate organizers for selecting this topic, and I have certain logic also, because if you divide our 2.5 centuries, nearly 250 years of time period, that is starting from 1770 to 2020, then mainly that era of 2.5 century, that is mainly divided into two parts. One that is related to industrial revolution, and if you check in industrial revolution part, you have various industries and developments, industrial development in the era of 1770 to 1853. Then along with textile, then that transportation industries come into the picture, along with rail, road and automobile industries up to 1970, that is full under development. And still along with this first phase of industrial revolution, with the help of that revolution, we carry out with computer technology, and that is started around in 1940. Now if you see all this revolution, then you find that for first 25 to 35 years, that is required to introductory phase of any technology. Then once it is established under research scale, then you have to adopt that technology in the industry, and you find that widespread adoption of that technology throughout the world. And during that phase only you are able to recover your money or wealth, create your wealth also. In introductory phase, yes, you have to invest heavily, but then after, once that technology is adopted by industries, then you have wealth creation phase, and then it is matured, and then rapid of any technology, new technology is coming out, and then it is carry over by that new technology to cover that old one. So if you see here, in 1997 to 2025, right now we are in 2020, unfortunately. But if you see here, that is introductory phase of the nanotechnology. And we find that in last 30 to 40 years, people are focusing on nanomaterials heavily in different fields. As Patil sir is also discussed, as Romila sir is also discussed about that. And then continue to that, once that technology is established in the market, then you have to switch over to the industries. So friends, next 50 to 70 years, based on history, you can say that next 50 to 70 years period, along with some other technologies, that is era of nanotechnology. And friends, believe me, it is right time to know about this technology, and we have to create awareness among all the research group about this nanotechnology and nanomaterials. So I congratulate all the organizers to select this topic and giving me an opportunity to talk on nanomaterials. So friends, we go ahead with this. And if you see here, so next phase is of nanotechnology. Now before I start my presentation, one very well-known proverb, that is, 1,000-mile journey begins with a small step. So whatever you do in the research, whether it is at very preliminary level, but believe me friends, whatever you do in the research having certain value to cover that 1,000-mile journey. So nothing is like a small step or big step. That is mindset, but every step having value. So please friend, I want to convey one message: put your step in the field of nanotechnology. This is right time. Now friends, we go ahead. I skip certain slide because this is introductory phase, and no need to explain what is nanotechnology at 10 raised to minus 9 meter here, because all of we having the doctorate degree, so I don't want to go into that. So I skip certain slide to curtain my presentation. But yes, one very important definition of nanotechnology, that is creation of useful material, device or any system at nanometer length scale to exploit various novel properties in that material, whether that properties are physical, chemical or biological in nature. And I like this definition too much, so I just want to share with you. Now I skip this slide because no need to explain what is a scale length of 10 raised to minus 9. But just for your information, I put one question here to understand what is nanotechnology. What is growth rate of your fingernail in terms of nanometer per second? And friends, estimated that growth rate of about 1 nanometer per second. So I discussed during this time your fingernail is increased by 3 to 4 nanometer in size. but it is difficult to visualize at naked eye. So no need to discuss this slide. So is nanotechnology is recently developed technologies? Friends, all of us know that no, it is not a recently developed technologies. So many years ago, before 500 or 1000 years ago, people are knowing, they were aware about the nanomaterials, but they were not aware about the, because lack of instrumentation, they don't know about the whatever they were doing, it is kind of nanomaterials or nanotechnology. So friends, I just want to give one example of that Lucas cup in British Museum, and that is developed in Roman glass makers 4th century. And what is beauty of this glass, as such it is shown as in green color, but if you enlighten lamp and put lamp inside that, then it is converted into red color. So it is believed that that is because of either gold or silver nanoparticles inside that glass. And it is backed by some another example also, that is also before 1000 years in the European church, where you have this kind of beautiful pictures and in different color glass, that is in different color. And nowadays people are talking that it is because of gold nanoparticles or silver nanoparticles at different nano size range. Say for example, gold nanoparticles here at 25 nm size, it is reflected as dark red. And if you see this glass here, you find that dark red color also. Similarly for silver nanoparticles, and which is backed by recent publication in 2010 in ACS journal. So for gold nanoparticles and silver nanoparticles at different nano size range of gold, either gold or silver, you have different color range. So friends, try to understand one thing. Before 1000 years or 1500 years ago, they know or they have control on particle size, whatever that we are talking at present, and they know technology to control the particle size. So friends, this is related to European countries. Now you may have question whether nanomaterials are available in ancient India. Answer is yes. Very well known example is kajal, and I skip this slide also, but because it is related to India, just I mention some of the points here. In Ayurveda, we all know, in Ayurveda, that Bhasma culture or Bhasma, it is used as a medicine in Ayurvedic medicine. So in Bhasma also they use gold, copper or even silver nanoparticles. And at bulk scale it is having different properties, and at nano scale after heating and grinding it is having different properties, and it is used in the medicine as a medicine. So in Ayurveda also there is culture of nanoparticles in ancient India. Similarly, in Qutub Minar, all of us know that it can withstand corrosion or all kind of environment or weather since last 1500 1600 years without facing much corrosive or much corrosion problem. Friends, try to understand, if we documented this technology very well, then probably we may lead the world in the technology, because still world is facing problem of corrosion. All of you are aware about corrosion issue in chemical industries. So if we have that technology at present, then just imagine that volume or scale or money that we generate in our country. But unfortunately it is not documented well. But one of the IIT, they found that nano coating or nano material right kind of nano material that is incorporated during metal composition. Similarly, sword of Tipu Sultan, carbon nanotubes or Damascus steel, or painting in Ajanta caves. Even Asian Paint today's give you guarantee about 7 years only if for exterior weather, exterior paint in weather condition. But we know that in Ajanta caves, since thousands years they painted very beautifully, and still that color is intact. So try to understand our godfathers having that technology of nanomaterial, but we have failed to, unfortunately we have failed to document it that. So, and whatever that I said, I think you say you claim these kind of things, but Nobel laureate of chemistry in 1996 Robert Kull also commented the same thing, that Indian craftsmen and artisans having knowledge of nanotechnology about 2000 years ago to make weapons as well as long lasting cave paintings. Just they are completely unaware about the practicing of that carbon chemistry. So friends, just this is for your understanding, and any nanomaterial lecture, if we forget this person, then it is not justifiable. So there is plenty of room at the bottom. Very famous lecture delivered by Nobel laureate Richard Feynman, and it is also available on YouTube. And I request all of you, whenever you have free time, listen that lecture to motivate yourself. Then after in 1986, that engine of creation, the coming era of nanotechnology, the book nicely written by Eric Drexler, and then history of nanotechnology till today in computer chips and all that things, we use nanomaterials in different applications. So just so next 50 years we have to depend on, heavily depend on these nanomaterials, whether it is healthcare and medicine sector or chemical technology sector or catalytic sector or ceramic industry, biotechnology sector. So friends, try to understand one most important point of nanomaterial, which is having enhanced or new properties observed at nanoscale. Say for example, gold or silver it as such at in bulk it is like shiny white in nature color, but at nanomaterial, nano particle size, it is having different colors. So try to understand the materials at nanoscale. Likewise, platinum kind of metal, if you use that as a catalyst in chemical industries at nanoscale, it is behave differently, drastically different results you are getting. Similarly, one most important point in nanotechnology, that is related to multidisciplinary approach. If anybody said that I am from physics background and my knowledge is sufficient to understand nanomaterials completely, then you are on the wrong track. Or if I claim that I am from engineering background and I said I have complete knowledge of nanomaterials, then also that is wrong argument. Friends, believe me, we have to develop a multidisciplinary approach like in European or foreign countries, and we have to join our hands, join together, whether you are from basic science field or from engineering or pharmacy field. So I like these 2 points very much and I want to share with you. So friends, big question is, it is just like talking of nanotechnology or actually it is used in the various products or in the industries? Let's take some of the example of nanotechnology or nanomaterials. Friends, in electronic sector, all of you are aware about computer chip and light emitting diodes, LEDs, that is widely used in camera, TV, computer, and all that things. Other than that, in biotechnology, people are talking about silver bandage of prevent infection, or even titanium dioxide phosphate coated titanium dioxide nano material for broken bones and implants. So these are the 2 examples. Just quickly I go through. Similarly, silver nanoparticles in cloth or even in nano wax or in cosmetic product, people are talking about metal oxide, zinc oxide, or titanium dioxide. So, and latest one, just Patil sir discuss about to detect COVID-19, even gold nanoparticles are used. So friends, this is about the uh, importance of nanotechnology. Then we quickly go through the nanoparticles or nanomaterials. So in my second part of the presentation, mainly we have to discuss divide this nanostructure material. We all know the material having length scale less than 100 nanometer, in the range of 0 to 100 nanometer, we consider it as nanomaterials. And friends, according to Siegel, it is divided into 4 parts. First, that is 0-dimensional material. Second, that is 1-dimensional or 1D material, 2D material, or 3D material. Friends, as all of we know that 0 dimension means all the dimensions x, y, and z dimensions that is less than 100 nanometer size, and nanoparticles, that is example of 0D material. Means 2 dimensions at nanoscale and 1 dimensions at more than 100 nanometer particle nanometer size, like nanowire, nanorods, nanotubes. So friends, I will give you example of this nanotube also in my case study. Similarly, 2D materials, friends, 1 dimension at nanoscale level and other 2 dimensions are more than 100 nanometer size, and example is nano coatings or nanofilms. Similarly, 3D materials, as such, no dimensions that is match with nanoscale, but as such that nanocrystalline size of the bulk material, that is at less than 100 nanometer size or less than 100 nanometer crystalline size. So that we consider under 3D material. So mainly I just give you idea about 0D to 3D. Now friends, how you synthesize this material? Now talk basic to our talk main focus. Mainly there are two approaches given or reported in the literature. One that is top down approach and another one that is bottom up approach. Top down approach mainly sputtering or etching method or laser ablation method or mechanical milling method, that is example of top down approach. Friends, it is something like you have rock and unnecessary part of the rock and converted that into sculpture. So that is example of top down approach. So opposite to that, that is another approach to synthesize nanomaterial, that is bottom up approach. In bottom up approach, we have various methods including precipitation method, sol gel method, pre-pyrolysis, physical vapor deposition method PVD, or chemical vapor deposition method CVD, or aerosol process. In this method, you have molecule or atoms and you try to join that molecules or atom together and convert it into bigger one, and by nucleation and growth theory, and you converted that into nanoparticle size range. It is something like you have different parts of the engine, car engine, you join all the parts and convert it into engine. So that is bottom up approach. So friends, mainly there are four type of materials that is reported in the literature: nanophase powder, nanostructured film, whether it is single layer film or multi-layer film or composite film, or nanotubes, nanowires, nanorods, or bulk powder, mainly nanocrystalline material, nanostructured composite. Friends, under this we have whether metal, ceramic, or composite particles, including crystalline in nature or quasi-crystalline in nature or even amorphous phase. Now, we have different routes, processing route for this nanomaterial: solid state route, liquid state route, and vapor phase route. And as I mentioned in top down approach, mechanical milling, that is solid state route, and in liquid state route you have sol gel, precipitation, hydrothermal method, gas atomization method, metal spinning method, etc. Out of all this method, mainly today in my talk, I give one method from top down approach, that is mechanical milling system, and one method that is from bottom up approach, sol gel method. So friends, quickly we go through that. What are the challenges involved in the field of nanomaterials? We all know always we are talking at laboratory level. From engineering viewpoint, still it is challenge how to convert, how to synthesize nanomaterial in the bulk. Because at laboratory level, if you are playing with 2 milligram or 3 milligram or 2 gram sample, it is not sufficient to fill the requirement of industries. You have to think about how you synthesize nanomaterial industrial scale. That is major challenge in the field of synthesis of nanomaterials. Other than this, another challenge that is related to reproducibility and control over the process, control over the particle size. What is meaning of this? Say for example, if any person come to me and say, sir, I need nanoparticles of gold having size of 50 nanometer. Now imagine whether it is possible to synthesize all the material having size 50 nanometer. Answer is 100% no. You have that mixture in the range of certain particle size. So it is again challenge to solve this kind of history, and you have perfect control with efficiency. I'm talking about efficiency. Yes, we know how to synthesize that material at nanoscale, but with efficiency. That is the major challenge in the field of nanomaterial. Friends, top down approach, I don't want to go into detail of that because it is not that much useful. It convert bulk material into very fine or ultra fine particles with the help of milling, and by using suitable kind of milling and give sufficient time to grind that material either in the presence of air or environment for oxidation or reduction, and convert that material in ultra fine particle size. So this is one approach that is people are talking about, and why this approach is already used in the industry, pharma industry also. And why this is widely accepted in pharma industries? Because it is having one advantage. It is so simple method. So friends, relatively simple method, mechanical milling system, and that's why it is adopted in pharma industry also. Even in certain dyes industries, they are preferred this kind of operation. But at the same time, this method having certain limitation, like it is tedious and time consuming. Other than that, there are chances of contamination of that milling media with your product. That is the major disadvantage of this mechanical milling system. And other than that, if you want to prepare a film of that material on the substrate, then this mechanical milling system is not useful to prepare film kind of structure on the substrate. So you have to go for some other kind of suitable kind of technologies. So another approach from top down approach, a bottom up approach, sorry, that is sol gel method route. Friends, out of all the methods reported in the literature under bottom up approach, worldwide, people are using sol gel method. And there are certain reason also why people are selecting sol gel method. It is considered under liquid processing route. Now, what is sol gel method? You have to create a nanomaterials with the help of sol gel method. And why it is widely used? Because in sol gel method, it is possible to synthesize nanomaterial even at room temperature. At normal temperature pressure condition also, you are in position to synthesize nanomaterial. Because why this point is important? Because so many times people are claiming that, sir, I also want to do research in the nanomaterial. Hello? Please. Ha. Sorry to interrupt because call from sir. So friends, sol gel method is having possible to synthesize your material at room temperature and pressure. It the bulk also. You have control on particles, certain kind of control on particle size also. So hello, is there any problem, sir, from my side?
No, sir. No, sir.
Can I continue?
Yes, yes, sir.
Okay, because I received call from you, so that's why. So now synthesis steps. In sol gel method, friends, you have to select suitable kind of precursor. And then by using that basic precursor of metal alkoxide, you have to hydrolyze that precursor with suitable solvent. I will brief you with case study also. Then give proper treatment to that solution, including stirring, pH control mainly, and you observe that gel is formed. Separate out that gel and give proper washing to that gel to remove whatever that byproduct that is formed during sol gel path. Then next step is you have to dry that material to remove water that is formed, because that gel is in wet form. You have to remove water molecule as well as certain kind of alcohol that is formed during sol gel process. I will brief you chemistry also. So you have to remove that. And finally, depending upon the material's nature, if it is hydroxide in nature, metal hydroxide, then you have to do calcination of that material to convert that metal hydroxide into metal oxide. Now friends, this is just chemistry of sol gel method. And if you synthesize, say for example, titanium dioxide in the lab, then initially you have precursor, then during sol is formed, then gel is formed. In this petri dish, if you see here, that gel is formed, and finally you have, after drying and calcination, you have titanium dioxide powder, right? So I just want to give you example, and in detail we'll discuss this example in case study. So friends, once you synthesize the material at laboratory level, your next task is how we characterize this nanomaterial. And as all of we know that we have different sophisticated tools to characterize nanomaterial that is synthesized in the lab. Say for example, XRD, which gives you idea about crystallite size or nature of the phase of that material, whether it is anatized or rutile in case of titanium dioxide, or even you may know about unit cell parameters also. Similarly, X-ray photoelectron spectroscopy, XPS, which give you idea about quantify the surface composition of that material or the chemical state, where oxidation state and bonding configuration of all the elements you are in a position to know. Similarly, in scanning electron microscopy, you will get surface topography of the material. Similarly, by using transmission electron microscopy, I just quickly go through this because all of we are having idea about the characterization tools. So transmission electron microscopy, you may know about crystallite size or aggregation, whether it aggregation is there or not. Similarly, surface area analyzer, that is used to know about specific surface of the material in terms of meter square per gram, or particle size analyzer, that gives you idea about particle size distribution in the material or powder. Thermal analyzer, including TGA, DTA, DSC, that is give you idea about the change in the properties along with the temperature change. So that is also a very useful instrument with respect to know effect of temperature on catalyst. Because as we know, in industrial practices, majority of the reaction that is at high temperature, high pressure reaction. So it is important instrument to know in the field of nanocatalysis. Similarly, ICP inductive coupled plasma is also useful to qualitative and quantitative elemental analysis of the material. So friends, I just give you idea about 0D to 3D approaches to synthesis and sol-gel methods mainly with characterization tools. So back to our part 3, how we synthesize nanomaterials or titanium dioxide in the lab. So we published this article in Journal of Industrial and Engineering Chemistry and received very good citation also, 41 citation. So before I discuss this case study, I brief you about the problem. Friends, before discussing TiO2 and its property, try to understand industrial problem. One very well-known petrochemical industries, no need to name it because all of you have idea about very well-known petrochemical industries in India, private industries, as well as one very well-known paint company in India, facing one problem of removal of aromatic carboxylic acid. Aromatic carboxylic acid like phthalic acid, benzoic acid, chlorobenzoic acid, nitrobenzoic acid from their wastewater. They have conventional treatment techniques, but after using all the techniques, they are facing that in treated water, huge amount of carboxylic acid that is still remaining, and they want to remove this aromatic carboxylic acid from the waste, and they approach us about the problem to solve this problem. And friends, we understand this problem in detail and found that advanced oxidation processes are capable enough to solve this issue. And under advanced oxidation processes, you have two kind of advanced oxidation processes. One that is homogeneous advanced oxidation processes and another one that is heterogeneous advanced oxidation processes. Mainly advanced oxidation processes are producing hydroxyl radical, OH dot radical. And this OH dot radical is so powerful to kill that organic molecule and convert that organic molecule into carbon dioxide and H2O. That is less harmful compound as compared to parent molecule. So we focus on this problem and think that why not we synthesize titanium dioxide in the lab, tune its property, and then apply this titanium dioxide to solve this industrial problem. And we focus on this aromatic carboxylic acid group because industry is having this problem. Friends, so this is problem statement, various treatment technology, because I already briefed you about advanced oxidation processes, so no need to go into detail. But in heterogeneous processes, we use titanium dioxide or zinc oxide as photocatalytic material. Now you may have questions, sir, why titanium dioxide is used as photocatalytic material? Friends, it is non-toxic in nature, TiO2, generally recognized as safe, GRAS. Now, friends, we all know TiO2, even that is used in our toothpaste or even in paint industry or even in so many cosmetic products. So it is considered as non-toxic in nature. Similarly, it is having good photocatalytic activity, strong oxidizing power, low cost as compared to other photocatalytic material, easy to synthesize by using sol gel method or even any suitable kind of any method. Then it is working at under room temperature and pressure condition. That is also an important point. So we focus on titanium dioxide and synthesize titanium dioxide in the lab. Now, before we discuss synthesis of this titanium dioxide, only limitation of this titanium dioxide is, friend, it is working under visible source only. It is not working under visible light source. So that is the limitation of titanium dioxide. And we focus on both the side, UV under titanium dioxide working under visible light as well as tuning its property. And at present, we receive one very good project from Pollution Control Board to synthesize titanium dioxide working under visible light active material. And I will share that things in detail. So friends, nanocrystalline material, as it is having very good surface area, so it is of interest. And what is mechanism of photocatalysis? First, I want to brief you that mechanism. We all know that in titanium dioxide or in any photocatalyst, you have a valence band and conduction bands. And when proper light intensity is focused on this nano material or TiO2 material, electron that is transferred from valence band to conduction band and hole that is generated at valence band. And this electron and hole that is taking part by using photo reduction and photo oxidation processes and generate OH dot radical. And this OH dot radical is removed to target that organic compound and convert that organic compound into CO2 and H2O. So this is about the mechanism of any photocatalytic material. Friends, so don't want to go into detail of chemistry much. We synthesize titanium dioxide by using sol gel method. We use precursor titanium tetraperoxide, TTIP, that is added in the methanol as a solvent. Then at room temperature, we add liquid ammonia solution to maintain pH in the range of 8 to 10, 9 to 10, and stir that in the range of just mild stirring is given to avoid that agglomeration. Then that is converted into gel type of material. We filter out that gel. Then finally we dry that gel to remove water and whatever alcohol that is formed during reaction. And then we calcine that temperature at different temperature in the range of 400 degrees centigrade to 650 degrees centigrade. Now, as we all know, titanium dioxide having mainly three phases: one anatized phase, another one that is rutile phase, and third one that is bruchite phase. Friends, it is believed that anatized phase is most active phase with respect to photocatalysis. So mainly we focus on anatized phase. And friends, once we synthesize this nanomaterial, nanocrystalline material, we characterize that material by using XRD. Now, XRD data shows that at 400 degrees centigrade, we have at nearly 25 degree 2 theta value, we have intense peak of anatized phase. And as that calcination temperature increase, the anatized phase is start to convert into rutile phase. And at higher temperature of 550 and 650 degrees centigrade, get more rutile phase as compared to anatized phase, and at very high temperature 650 degrees centigrade, that anatized phase is removed from the material. And in summary, we try to find that crystallite size of the material, and if you see this result, we are able to produce nano material, nano crystalline material having size 23 nm, purely anatized phase for in the case of 400 degrees centigrade calcine temperature sample. And as the temperature increase, your crystallite size is also increased because of agglomeration, and as size is increased, you observe decrease in that surface area of the material. So sample calcine at 400 degrees centigrade, we have 23 nanometer crystallite size with 37 meter square per gram of specific surface or surface area. Friends, then we do FTIR also to know that characteristic peak of the TiO bond as well as that OH bonding. And as that temperature increase, that OH bonding that is also removed here, and that is disappear nearly 3400 centimeter inverse peak. So I don't want to go into chemistry side much in FTIR spectra. Friends, then we do thermal analyzer. So because you may have questions, sir, why you directly go for 400 degrees centigrade calcination temperature? Why it is not possible to calcine at 300 degrees centigrade? Friends, to decide that temperature, we carried out thermal analysis. And in thermal analysis, if you see here, you observe that loss of the material loss because of removal of water and alcohol molecule in up to 200 degrees centigrade, and you observe sharp peak, decline peak at 400 degrees centigrade, which indicates that at that temperature, that amorphous material that is converted into crystallite material. So we select 400 degrees centigrade temperature. So friends, experimental setup, we have small setup of photocatalytic reactor where you have to put UV bulb in quartz tube, and then outside that you have to put your solution and add your catalytic material. Along with that, you have to supply air because oxygen having important role in photocatalytic mechanism. So you have to supply air also, and then you have to take sample at regular interval and analyze that sample with the help of HPLC. I don't want to go into detail of HPLC right now. If you are having any interest, you please mail me. I will send that entire article to you, friends. And we study operational parameters because from industrial viewpoint, it is always important to know about optimization of parameters, whether in terms of catalytic dose or concentration or kinetic study. So friends, I am happy to, this is HPLC method, and I don't want to go into detail of HPLC. So friends, if you see here with catalyst loading, if we add catalyst in the range of 1 gram per liter to 5 gram per liter, as catalyst dose increase, your degradation rate is also increased up to 2.5 gram per liter. But once again, if you double the dose, you are not getting that much increment in efficiency because you observe screening effect. Because of more number of particles inside that water, that synthetic waste water, the light that is not penetrate on each particle, and that particle create barrier in between also. So that is considered as screening effect. So at very high catalyst loading or dose, you are not getting that much hi-fi results. So you have to optimize this parameter. And I am happy to share that result. Around 180 minutes time to 3 hours time, we are in position to remove nearly 85 to 90% of that organic molecule from the wastewater. So friends, try to understand industries facing problem of removal of that organic compounds from the treated wastewater. We consider that water and try to remove that compounds from the wastewater, and we are getting efficiency in the range of 85 to 90%. Friends, other than that, we similar experiment we carried out for 4 different acid, and we found that phthalic acid is strongly degraded by photocatalytic material, but in the case of other materials like orthonitrobenzoic acid or orthochlorobenzoic acid or benzoic acid, effective. You get result in the range of 30 to 40% removal. There is chemistry behind that, and we propose this chemistry in this article, and that's why it is selected in the journal. So at present I don't want to discuss here that degradation mechanism of each molecule, but we propose this mechanism in the article. So degradation mechanism, mainly it is related to attack of or joining that hydroxyl radical with molecule, and then that hydroxyl radical break that molecule and convert into CO2 and H2O. So friends, we successfully solve industrial problem. And then, hello, all of you are with me? Anyone? Hello friends.
Yes, sir. Yes.
Can I continue?
Yes, sir. Yes.
Okay, thank you very much. So friends, we successfully solve this industrial problem, but during this problem, we realize that if we want to improve efficiency of photocatalytic material, so that is, hello, please. Okay. So friends, we realize that if we want to improve efficiency of that nanomaterials, we have to change its property by dope some suitable kind of metal into titanium dioxide structure. And friends, believe me, we try with very simple experimental facility in our lab, and publish this article of synthesis of silver doped titanium dioxide and photocatalytic properties, and it is selected in INDC research, ACS journal, Industrial and Engineering Chemistry Research Journal, and in last 5 years it is having citation of nearly 100 citation, 95 citation worldwide. It is accepted, and people are believe that it is very simple technique of doping. Friends, so just I want to share that results, main results, not go into detail, but if you have interest, feel free to discuss with me. So friends, just we synthesize silver doped titanium dioxide by using same method, but by using silver nitrate as doping material in sol-gel process. We modify that process, use silver nitrate also to synthesize titanium dioxide, and then finally characterize that material. And I'm happy to share that we synthesize material in the range of 1 to 5% of 8% of Ag silver in titanium dioxide, and theoretical value that is 1 to 5%, and estimated value, if you see that result that is received from ICP, inductive coupled plasma, then in the case of 1% successfully, that silver doping is 0.81% to in the range of almost 100%. So friends, it is very simple process for doping, as Patil sir is also discuss about dop TiO2 for some different application, and if Patil sir wants, we are ready to send our material for your testing also, sir. So this is very simple technique to dope silver or even gold nanoparticles or even any metal doping in any metal oxide particle. So friends, we synthesize this successfully, and if you see results here, beauty of this synthesis method is you have very narrow particle size distribution. Friends, I discussed this point during challenges faced in nanostructure synthesis. You don't have any control on particle size, but successfully we synthesize very narrow size range particle. If you see here, it is in the range of 50 nanometer at 400 degrees centigrade to in the case of 600 degrees centigrade 80 nanometer size. So with the help of silver, we are in position to decrease even particle size also, and that is reflected in the results of XRD data. So friends, if you see here that particle size in 1% silver doping size, we are in position to get 54 nanometer particle size, and we carried out this analysis with the help of Malvern nanosizer, particle size analyzer by DLS method. Now, if you check here, if you remember my last discussion, I am getting to able surface area that is maximum 37 meters square per gram in the case of TiO2 material. and by doping we double that area. Friends, in catalysis you have importance of available surface area, and I am happy to share with you we double the surface area than that bare titanium dioxide in metal doped titanium dioxide, and it is 82 meters square per gram. So these are some results to share with you, and maybe you find some good things and motivate through these results. Similarly, SAM results, SAM and IDEX results. Friends, if you see this slide, beautiful spherical particles can be observed throughout the slide. So it is also support that you have control on that particle size. It is easy to talk, but when you go to lab and try to do all these things, you may realize how much difficult it is. And I am happy to share with you, we synthesize it successfully with almost spherical particle size. Friends, same image of this AG dot spherical particle size, and in the case of pure TiO2, you find agglomeration or bigger size spherical particle. Then we use this silver doped titanium dioxide in the case of same molecule, that is phthalic acid, industrial problem. And happy to share that in the case of 1% titanium dioxide, we are getting better activity as compared to pure titanium dioxide or higher percentage of doped titanium dioxide. So friends, we achieve that by doping. We reduce that removal rate, removal time from 3 hours 85 to 90% to up to 1 hour time with the help of silver doped titanium dioxide nanocrystalline materials. So, and mechanism of, or what is, you may have questions, sir, what is role of silver in titanium dioxide? So silver is electron trapper. Normally in any photocatalytic material, you are facing problem of electron hole recombination rate. Because of that recombination, your efficiency of photocatalytic material is reduced. But if you add suitable kind of dopant in suitable amount in titanium dioxide or any photocatalytic material, which is act as a electron trapper, and that's why that electron hole recombination rate is delayed, and you have more number of electrons available for the reaction, and at the same time hole is also available for the reaction, so your efficiency may improve. That is hypothesis and we prove it, and that is accepted by INDC journal also. So friends, other than that, we try to, this is about 3D material. Then we thought that why not we try for 2D material, and we try to develop nanotube in laboratory. I don't want to go into detail of all these things, but if you see this picture of SAM and TAM picture, you realize that you have beautiful nanotubes with diameter 8.3 nanometer and wall thickness 2 nanometer. So friends, now it is clear why I am talking about 2D material, because we successfully synthesized 2D material also. We successfully synthesized 2D material also. 2D and 3D now we synthesize. Now we are focusing on 1D and 0D material in future. So friends, if you see this result, then beautifully that tube kind of structure we synthesize with diameter 8.3 nanometer, outer diameter that is 8.3 nanometer, and this wall thickness that is 2 nanometer. So this is very kind of encouraging results in the lab. And friends, we use this nano material for the removal of organic compound, and happy to share with you, we check its property with standard titanium dioxide. Worldwide, it is accepted that Degussa P25 Degussa, that is one of the best photocatalytic material in the world. And friends, we try to synthesize material having superior property than Degussa P25. And if you see this property of our titanium nanotube, it is 185 meters square per gram, almost 3.5 to 4 times higher surface area. Not only surface area is higher, in terms of activity, we are getting better result than Degussa P25. And we publish this as a book chapter. So friends, we try to synthesize some of the nanomaterials 3D and 2D in our lab, and successfully used these nanomaterials to remove certain organic molecules from wastewater, that is industrial wastewater. So before I conclude my talk, I want to share one story, that is dialogue between sun and the candle. When sun went down in the evening, he asked everyone on the earth, who will take up my responsibility of providing light? And no one replied, because it is not possible for anyone to take place of that sun. But a candle in a cabin answered, my lord, I cannot light up the whole universe as you do, but I will do my best to light up this small room. With this message, thank you very much for providing me an opportunity to interact with people, learned people like you. And I am very much impressed with the presentation of Patil sir also. And in future, if they permit us, we'll definitely do some collaborative research work. So I acknowledge Dharamsi Desai University, Department of Chemical Engineering, my teammates and students, to because without students you can't do all these things. So they, that is from our side, but heart and hand and leg, that is from student side. So thank you friends, thank you very much. And recently we published one book on photocatalytic nanomaterials for environmental applications. My mail ID vggandhi.ch@ddu.ac.in. Thank you very much friends, and session is open for question answer.
Thank you, sir.
Ha, friends. I hope you enjoyed this talk.
Thank you, sir. Thank you very much for your excellent presentation. May I now request the delegate participants to ask question to Dr. Gandhi, sir.
There is one question from audience.
Please, sir.
Please present, sir. Read it.
Elaborate doping method.
Okay. Because of time limit and certain issues, I discuss that in length. But I am happy if you read my paper, and in that paper we completely describe that method. Apart from that, how we synthesize or dope that material, same sol gel method, but use that silver nitrate in calculated amount, dissolve that silver nitrate in suitable kind of solvent, and slowly add that silver nitrate during synthesis step. In controlled manner, add your silver nitrate during synthesis step, and you will get very good result. But yes, some trial and error kind of thing is required to dope it properly. If you do that doping with very high speed, you are not getting good result. Or if you do doping with very low speed, then also you may not get good result. So you have to do certain trial and error in laboratory. But yes, this method is very simple. In one beaker you have to select metal precursor, metal alkoxide precursor in solvent. In another method you have to prepare dopant, suitable kind of dopant, dissolve in the solvent, mix it, hydrolyze it. But friends, it is given in my paper also. Please.
Thank you, sir. Is there any other question on the part of the participants? Gade sir, is there any other question? No.
No, sir, there is no more question.
Okay, thank you, sir. Thank you for your excellent presentation. Now, last but not the least, may I request Dr. Kirti Desai ma'am to posit vote of thanks. Dr. Kirti Desai ma'am, for the entire web conference.
Thank you, sir. I am audible, sir.
Yes, ma'am. Please continue.
Yes, sir. Thank you, sir. Thank you, Gandhi, sir. Very detailed knowledge of nanotechnology and synthesis method. nanotechnology is very important. Of nanotechnology is multidisciplinary use due to importance of nanotechnology. Thank you, sir, again. Then last part, vote of thanks. Honorable chief guest, present excellence, teachers and my dear friends, I thank college for giving me an opportunity to express my gratitude on this special day. It is an important for day used today that we have hosted the online seminar, that is webinar, on recent developments in material science and more than we have 260 representative and more than colleges and universities participating in this ceremony. This is huge success in itself. On behalf of the Arts, Commerce and Science College, Dharur, I express I heartfelt thanks to Honorable Prakash Dada Solunke, MLA, Maharashtra State and President MSP Mandals, Aurangabad, Honorable Satish Bhau Chavan, MLC, Maharashtra State Secretary, MSP Mandal, Aurangabad, and Honorable Jaising Bhaiya Sulunke, Chair Member, College Development Committee, ACS College Dharur. Then Honorable Sawant Sir, Honorable Ram Shingare Sir, Honorable Indrajit Jadhav Sir, Honorable Ajit Singh Dikkat Sir, Honorable Sri Lobaji Chauhan Sir, then other Honorable V.O.2 Sri Jogade Sir, Honorable Sri Gaikwad Sir, and our Honorable Chairperson and Principal, Dr. S.J. Sirsat Sir. Thank you, sir. Then, main speaker of respected K.M. Jadhav Sir, very detailed knowledge of nanotechnology is very important. Then, resource person second, Vikas Patil, Rohit, knowledge of nanotechnology, and third person Vikas Patil sir with detailed knowledge of nanotechnology in COVID-19 pandemic, and last person resource person Dr. Vimal Gandhi sir. Thank you sir, grateful lecture and very informative lecture for this. I would like to thanks all the respected representatives, participants who have blessed us with their presence. I would like to thanks the organizing team and co-convener Dr. L.B. Jadwar sir and myself, teachers and staff members. Without you all, this webinar would not have been possible. Thank you very much once again. Special thanks Dr. Ganjawar sir and Professor Sagar sir and Professor Gade sir. And I conclude to thanks again for making this webinar successfully completed. We have to end over this program. Thanks, sir. Hello.
Hello.
Hello,
Thank
sir.
you, sir. Thank you for today's end of this webinar. I request all dear participants to fill up the online feedback form. Thank you very much. Thanks a lot.
I have shared feedback link within the chat box. Participants are requested to fill the feedback link. Thank you.
Thank you. Can I leave?
Yes, sir.
Thank you, sir.
Thank you.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.